This is a good MOSFET. Let's check. We have about 0.68, means this is a good triac. We have a reading between the base and collector, 500 drop voltage, about 500. It contains two diodes connected together, about 130. This is a good Schottky diode. 12 volt output, regulator, input to ground to output. Between the ground and the output, we get a reading. This is good. 1000, as you can see, about 1000. We should get a reading, as you can see, about 1000. The relay contains 4 terminals. So 2 terminals for inductor and 2 other terminals for switch. Here, this terminal is not used. Here we get a reading. Here I should get a double value. We have a short circuit, 3 amps over here, 250 volt. Do you see 500 drop voltage? We have the first diode. Here we have the second diode. This collector emitter. So between collector and emitter, we have a reading. In the cathode and the other probe in the anode, we get a reading in the multimeter. The capacitor charge and discharge means this is good capacitor. About 0 in the multimeter, we have 1.1 ohm, 0.9. We should get a high reading, as you can see, in the multimeter. If you get a short or a low reading like this, means the capacitor is shorted or the IC near to the capacitor is shorted. Let's check those also. Good.
Hi, please pay attention. This is a very important video for every electronic technician and engineer. You're going to learn and see all electronic components, names and functions. You're going also to learn how to test using the multimeter all electronic components. We're gonna see 2 parts in this video. The first part is a theory part. The second part is a practical part. So let's get started with the theory part, but please don't forget to subscribe, share the video and like the video, because your likes motivate me to create more and more videos for you. After watching the theory part, let's now begin the practical part. So the first component we have here, electrolytic capacitor. Basically the electrolytic capacitor contains two terminals, as you can see. Here we have the negative terminal, and over here we have the positive terminal. We call this capacitor polarized capacitor. So it has some characteristics including voltage and farad. Here we have its microfarad. We have 2200 microfarad and 360 volt. So the maximum voltage for this capacitor is 360 volt. There is basically many dimension and shape in this capacitor. For this, for example, we have 680 microfarad and 220 volt. It has, of course, two terminals, negative terminal and positive terminal. That's why we called it polarized capacitor. The purpose of this kind of capacitor is to filter the current and to get a continuous current. So depending on the type and the shape and the dimension of the capacitor, the characteristics are changed. For this, for example, we have 1000 microfarad and 25 volt. The maximum voltage is 25 volt. So the second component, inductor or winding, as you can see, basically this is an inductor. It contains basically two inductors, as you can see. We have two colors over here. We have a red color and we have this orange color. Okay, so this is the first inductor. Each inductor has two terminals, and this is the second inductor. So basically the inductors has as a purpose to increase the current in the circuit. Here we have another inductor, as you can see. It contains just one winding or one inductor. Here we have another inductor. We find basically this kind of inductor into desktop motherboard. Okay, so you can test this inductor using the multimeter, and by choosing the continuity option in the multimeter, you should get a very low resistance or a buzzer in the multimeter. This inductor also we find it near to the processor in the desktop motherboard. Okay, so the inductor has as a purpose to increase the current. Now we have the relay, as you can see. This is the relay. So basically the relay contains 4 pins. 2 pins for inductor, as you can see. We have inductor, and the other 2 pins are basically for a switch. The relay has some characteristics in 10. So the voltage here we have 24 voltage and 10 amps. So this relay transform 24 volt to 240 volt. Okay, so we have another relay here, as you can see. So always you should find inductor and a switch. Here we have inductor, and over here we have switch. Once the inductor receives the power, the switch will be closed. Okay, and then the power will pass from one terminal to another. So the characteristics for this relay, as you can see, is 24 volt and 125 volt. So it transforms 24 volt to 125 volt. Okay, depending on the circuit. Next we have rectifier, bridge rectifier. Okay, so these rectifiers basically are used in the switch mode power supply. Okay, in order to transform the voltage from alternating voltage to continuous voltage. As you can see here, for the bridge rectifier, it has 4 pins. Okay, so I will show you in the next lectures how to test the bridge rectifier using the multimeter. Don't worry, I will teach you how to test all these components using the multimeter in the next lectures. So next we have MOSFETs. Basically this kind of component, it could be a MOSFET, voltage regulators, oscillators, Schottky diode, etc. So we base on the part number above it. Okay, for example, this could be a voltage regulator or oscillator. Okay, but for this one, for example, over here we have 2 diodes. This is basically the Schottky diode or rectifier. Okay, we find this kind of 3-terminal component in the switch mode power supply. That's why always you should use the part number in order to identify the type of this kind of component. It could be with 3 terminals or even 4 terminals. So here we have, this is an IC basically. This is dual inline package IC. This is an IC, but specifically this IC is the BIOS, the basic input output system IC. So here we have this capacitor. This is a very known capacitor, CPB61, with 450 volts, as you can see, and 50-60 hertz. So basically this capacitor is used to remove the interference in the circuit. There is many types of capacitors, as you can see. We use this kind of capacitor basically to remove the interference frequency, but for the first capacitor we use it especially in fans. We called it sometimes starter capacitor. And here we have transformer, as you can see. I am going to show you how to test all these components. Of course, the transformer has two parts or two stages, the primary stage and the secondary stage. This is the electromagnetic interference inductor. Okay, so this is not a transformer. This basically is used to remove and to eliminate the interference in the circuit. Here we have another transformer that contains two inductors or winding, a primary winding and secondary winding. Here we have a switch. Okay, this is a switch. We find this kind of switch in laptops, in computer motherboards. I'm going to show you how to test this kind of switch. It has basically 4 pins or 2 pins. So 2 pins here for ground and 2 pins for 3 volts, 3.3 volts. Okay, and over here we have another switch. Basically the switch has just 2 terminals. Okay, one terminal for ground, connected to ground, and the other one connected to 3.3 volt. Once you click it, you shunt between 3.3 volt and the ground, and the laptop will turn on. Here basically we have some oscillators. We find this kind of oscillators in the switch mode power supply. Okay, this is controller. They control the power. They control exactly the transformers and the power in the motherboard. We're gonna see all this in the next lectures. And here basically this is a MOSFET. Okay, this is a voltage regulator that transform from 1 volt to another volt. This is a voltage regulator. Okay, and this is the heatsink. The voltage regulator in the switch mode power supply always need a heatsink in order to cool down it. Okay, here basically this is capacitors, ceramic capacitors. Okay, this is ceramic capacitors. We find sometimes the ballast capacitors in this shape, but this is ceramic capacitors. So the ceramic capacitors has the purpose to remove the noise in the circuit. So we called it filtering capacitors. Then we have here transistors. Okay, this is transistors, not MOSFET. So the transistor has the base, collector, and emitter. Okay, and of course I'm going to show you in the next lecture how to test the transistor, how to identify the collector, how to identify the emitter, etc. And over here we have fuses. All these components are fuses. Okay, protection component. The fuse protect the circuit for high current. For example, this fuse, this is a blown fuse. This fuse is damaged, failed. Do you see here the wire inside it? The wire is cutted, okay, is burned. So of course the fuse has 2 main characteristics, so the voltage and the amps. So let's see the characteristics for this fuse. For example, so we have 3 amps, as you can see, and 250 volts. So this fuse is failed. You should replace it with another fuse with the same characteristics, 3 amps, 250 volts. And of course there is many types of fuses. So let's see the characteristics of this fuse also. So let's zoom a little bit in order to see the characteristics. So as you can see, we have 10 amps, okay, 10 amps and 250 volts. So the wire will be in this fuse very thick. And of course there is many other types of fuses. For example, this is another fuse, okay, that is covered. So remember, the fuse has 2 characteristics, amps and voltage. So here we have resistors. Okay, this is basically resistors. Of course, resistors, you can identify the capacity of any resistor using just colors. Okay, or of course you can identify it using the multimeter. I'm going to show you all this in the next lectures. Then we have this component, we called it crystal oscillator. This is a crystal oscillator that generates the timing and the clock. Always will find this kind of crystal oscillator in the laptop motherboard and computer motherboard, near to the clock generator, near to the IC, to the BIOS, to the super IO, etc. So if we focus here, let's see how much megahertz in this crystal oscillator we have. As you can see, about 25 megahertz. So over here we have electrolytic capacitor or chemical capacitor. This is another type of electrolytic capacitor. We can call it SMD capacitors. We find this kind of capacitors in the computer motherboard and also in the laptop motherboard. Okay, so basically it has two characteristics: the voltage and the unit in farad. For example, this one we have 390 volts microfarad and 25 volts. Okay, and of course it has two terminals, negative terminal and positive terminal. Of course, sometimes you can find some capacitors with a code on it, just letters. I'm going to show you in the next lectures all about this. So the capacitors, we use it to filter and to make the voltage a continuous voltage. So here we have another capacitor. This is basically a capacitor that is used in the circuit. This capacitor connects the line voltage with the neutral voltage in order to remove the interference in the circuit. So this is basically a CMOS battery. Okay, we find many types of battery. For example, for this one, this is for computer. Its reference is CR2032. This is for computer and laptops. Okay, this is the code, the part number for this battery. Here we have another battery, as you can see. This is also for laptop. Okay, we have another battery for laptop, and the fourth one is for calculator. So this small component basically is a ceramic capacitor or PF capacitor, picofarad capacitor. We find it everywhere in computer motherboard. This is a very important component that removes the noise in the circuit. So here we have diodes, as you can see. This is diodes, normal diodes, as you can see, with cathode and anode. Okay, as you can see, we have cathode, anode, and here we have the cathode. Okay, so this capacitor let the current to pass just in one direction from the anode to the cathode. We use often this component to rectify the current and to protect some circuit. Here we have the Zener diode that we use to stabilize the current in the circuits. Here we have cathode, as you can see, Zener diode, stabilization of current in the circuit. So this is another capacitor. We called it tantalum capacitor. Tantalum capacitor. This is basically a polarized capacitor, as you can see, polarized capacitor. Also, we use it in everywhere in any circuit in the computer. So here we have another oscillator. Basically this component include inside it two components, an oscillator IC and the MOSFET. We use this kind of IC in the switch mode power supply. This one also in the switch mode power supply. So this one is connected to its heatsink. So the heatsink is very important for this kind of component. So here, this is a very dangerous component. This is a high tension inductor, as you can see, high voltage. Never touch this component. Please pay attention. Never touch this kind of component in the circuit. Okay? Never touch it. This is a high voltage component. We'll find it in television and in some devices. So this component basically, it's not diode, it's not resistor. This is inductor. Okay? You can find this kind of inductor, for example, in computer motherboard or other devices. And here basically we have LEDs. Okay, this is LEDs, light emitting diodes. This is LEDs. I'm going to show you how to test these LEDs, okay, in the next lectures. And of course, next to the LEDs, we have some resistors. You can see SMD resistors, as you can see. And also we have some transistors and capacitors, ceramic capacitor, etc. We're gonna study all this. And of course, here we have an IC or regulator IC. So here, this is a very important component that I'm going to teach you. All right. So this is the motor. The motor contains two parts inside it, a rotor and a stator. Okay, so this is the rotor. Okay, here I have plus and minus two terminals in order to power it. So this is the rotor and the stator inside it. I'm showing you how. So here, this is the inside of the motor. So here in this true, the rotor, and this is the stator. This inductors means stator, a fixed component and a moving component. I have a video in my channel that explains the motor, how the motor works. So here we have some connectors, as you can see. Okay, the connectors, don't neglect the connectors. The connectors sometimes is the cause of the failure in the motherboard and other devices. So this is a connector with 2 pins, a connector with 3 pins, as you can see. And here we have USB connectors. It contains 4 pins. Okay, 4 pins. So this pin is for 5 volts, minus D data, plus D data, and the ground. Okay. I'm going to show you how to test it using the multimeter in the next lectures. Here we have an on-off button. This is on-off button with 2 terminals. You can find 2 terminals or even 3 terminals. So here we have a selector. This is another switch, but we call it selector between 115 volt and 230 volt. Okay, so this is selector with 2 terminals, of course. You can find others with 3 terminals or even 4 terminals. So here this is power jack. Okay, this is a power jack. So find this power jack in motherboards. Okay, when this power jack is failed, the motherboard will be a dead motherboard. So there is power jacks with 2 terminals, with 3 terminals. Okay, and here we have the heatsink. So please guys, don't neglect the heatsinks. The heatsinks has one of the most important role in every device. Without these heatsinks, everything will burn out in the motherboard. The CPU need heatsink, the NOT bridge need heatsink, the IC, the graphic card, the MOSFET, everything needs the heatsink, especially the main component in every device need heatsink. So please don't neglect heatsink. And of course here we have the plug, the power plug that will connect to the power jack. It contains 2 terminals. I can show you also for beginners, of course, how to check and how to test using the multimeter this kind of component.
You can find many types of ceramic capacitors in laptop motherboards and computer motherboards. For example, you can find this kind of ceramic capacitors, big ceramic capacitors. Also here we have other ceramic capacitors, as you can see over here. So to test the ceramic capacitors, we gonna use, as you can see here, the continuity option. We're gonna use this option. Okay. So let's begin and test, for example, this big capacitors over here. So we can just put 1 probe here, okay, and the other probe into other terminals. Do you see? We get a reading here in the multimeter. We should not get a reading like this, as 0 in the multimeter. If we get a reading like this, means the capacitor is shorted. Okay, so let's check the second one over here. Okay, we have here the same reading. So these capacitors are good. So I want to add here that, for example, this capacitor is not like this one in terms of size. So if you have, for example, a failed capacitor like this one, you should replace it with another ceramic capacitor with the same size and same color, because above ceramic capacitors we don't have here values like, for example, tantalum capacitors or electrolytic capacitors. That's why if you find a failed ceramic capacitor, you should replace it with another one with the same color and same size. This, for example, and this are same, okay? But as you can see here, this one, for example, and this one are not the same. This is a brown color, and this color, as you can see, is not like this one. Those also over here are not the same as this one. So, for example, if this one is failed, do not replace it by this one or this one. You should replace it by another one. For example, these 2 are the same. These 2 here are same. This one, no. Okay, so this is how you can replace ceramic capacitors. Here also, as you can see, if, for example, this one is failed, we can replace it with another one with the same size and same color. We have here the processor. Okay, So under the processor directly we have ceramic capacitors, many ceramic capacitors. So let's check, for example, this ceramic capacitors. Okay, so this is the ceramic capacitors under the CPU socket. Okay, so let's check any ceramic capacitor. Let's check this one, for example. Do you see we get in the multimeter a very low resistors? Let's check this one also. As you can see, this is a short. No, this is not a short. I will prove to you. So let's go directly and remove the processor. So let's remove the processor over here. Okay, let me remove the processor. As you can see, now the processor is removed. Okay, so let's check again the ceramic capacitors. So one probe here and the other probe here. Do you see in the multimeter we get 700? Let's check this one also. 700. Okay, if we put back the processor, no, the processor is installed. So let's check again just to make sure. Just to make sure. So one probe here, the other probe here, as you can see in the multimeter. We get a short. This is not a short. So please, guys, remember, always for chipsets, okay? Always for chipsets like the CPU, the graphic card or North Bridge, and the ICH, always the ceramic capacitors, as you can see, that you're gonna find in the back of the chipsets. You will usually, not usually, but always you will find a very low resistance. This low resistance is not a short circuit. So please remember, because many technicians find like this short and try to figure out where is the short circuit exactly. But no short circuit, it's not the short circuit, it's normal. How to test diodes inside the board. Okay, so let's begin first with inside the board. Okay, so let's begin with diodes. So for example, let's pick this one, the first one here. So here, as you can see, we have cathode, and here we have anode. So I will put the black probe in the cathode, as you can see, and the red probe in the anode. And I should get a reading in the multimeter, as you can see. I get a reading in the multimeter, okay? So when I swap the probes, as you can see, okay? So nothing in the multimeter. Means this is a good diode. So let's check this one also, as you can see over here. So we have here cathode, okay? And here we have anode. So let's put the black probe in the cathode, like this, and the red probe in the anode. We should get a reading, as you can see in the multimeter. So if I swap the probes of multimeter, I should not get anything in the multimeter, okay? But for the board, basically, it's not a 100% accurate. If you want to check whether the diode is good or not, you should normally take the diode outside the board, like this one, okay? And check it using the same working principle. We have cathode here, and we have anode here. So if I put the black probe in the cathode, as you can see, okay, and the red probe in the anode, I get the red in the multimeter, okay? So if I swap the probes, as you can see, so no reading in the multimeter, okay? Means this is a good guide. So, but in the board, as I told you before, you can, when you swap the probes, you could get a reading, because this diode could be in parallel with other components, like for example, another diode or a resistor or a MOSFET or a transistor, etc. So now let's test the bridge rectifier. As you can see over here, this is basically bridge rectifier, okay? So this bridge rectifier basically is used to make the voltage a continuous voltage. Okay, we use this kind of bridges into switch mode power supply. So to test this component, you should put here we have minus, here we have plus. The same for this one. We have here minus, here plus, and here we have AC. This 2 for AC, this 2 also for AC. So to test this kind of component, I show you how. So always you should put the multimeter into continuity option or diode option, and then here we have the read probe of the multimeter. We should put it here into negative of the bridge rectifier, and the black probe once here, as you can see, we get a reading, and if we move it to other AC terminal, we get a reading. And here we should get a double reading or a sample reading. Means this bridge rectifier is a good bridge rectifier. But if I swap the probes, as you can see, so the black probe here, I should not get anything here. Here also nothing. Here also nothing. Means this is a good bridge rectifier. So let's check this one also, as you can see over here. So let's put the read probe here in the negative terminal. Okay, like this. Okay, and then check the first pin, we get a reading. The second one, we get a reading. The fourth one, we get a reading also. But if I swap the probes, as you can see, nothing here, nothing here, and nothing here. Means this bridge rectifier also is a good bridge rectifier. So let's check these two fuses, as you can see. Here, basically, the fuses are sample to test. To check the fuses, basically, it's very simple. Here we have a serviceable fuse, as you can see, and over here we have a bad fuse, a burned one. Okay, so to test the fuse, you should just put one probe of multimeter here and another here, and of course in the continuity option of the multimeter. So let's check. So I should just put one probe here, as you can see over here, and another here, and I get, as you can see here, I should get a very low, as you can see, resistor in the multimeter and a buzzer. Okay, so this is a good fuse. But for this one, let's do the same. One probe here and another here. Nothing in the multimeter. Means this is a bad fuse. Okay, so for the fuse, for example, if you have a bad fuse, you should replace it with another fuse with the same characteristics. So for this one, for example, the characteristics for this fuse, as you can see here, so we have 3 amps, okay, and for the voltage we have 250 volt. So you should replace it with another fuse with the same characteristics. Okay, so 3 amps, 250 volt. So let's check this one also. So also, as you can see, we have 3 amps and 250 volt. So we can replace this bad one with this one. Okay. So for the capacitors, how can we check the capacitors? So we have here basically 3 capacitors that I'm going to show you how to check. So basically this is a bad one, and these 2 are good. So let's check the good one. Okay, you can just always, I work with the same mode in the multimeter. Okay, continuity mode and diode mode. So I can just put one probe here, okay, and the other here, and look to the multimeter. So if I swap, you see the cap, and if I swap the probes, the same thing. So the capacitor charge and discharge. Means this is a good capacitor. But for this one, let's do the same. As you can see, nothing happened in the multimeter. if I swap the probes, nothing. So this is basically a dead capacitor, because a dead capacitor could give a continuity in its terminal or no sign of life. So for this one, for example, this is a serviceable one. So this capacitor basically, as you can see, is for laptop, and also you can find it in the computer or desktop motherboard. Okay, so let's check it. We should get in the multimeter charge discharge. Okay, so let's check. You can see in the multimeter charge discharge. If I swap the probes, you see charge discharge. Okay, means this is a good capacitor. Okay. So for the inductor, here we have, as you can see, inductor. So basically for the inductor is just a wire, as you can see, a winded wire. So always we can use this mode, the continuity mode, and check this inductor. For the inductor, you should get a continuity and a buzzer, so a very low resistor. So let's check. As you can see in the multimeter, very low resistors. Okay, means this is good. It's not a cathode one. Let's check this one also. As you can see, low resistance in the multimeter and buzzer, means this is also a good inductor. Okay, so here basically we have, as you can see here, a component with two diodes. As you can see here, we have its reference MPR 100 CT, as you can see. So basically to check or to test this component easy, because we have two diodes, as you can see, connected together. So we can just test this diode over here. Okay, and then test this one also. So let's check. So here we have the anode and here we have the cathode. We get a reading. If I swap the probes, I should not get anything good. And for this one also, here we have the anode and here we have the cathode. We get a reading, and if I swap the probes, nothing in the multimeter, means also this is good. Okay, so for this kind of capacitor, as you can see, you can find this kind of capacitor in the switch mode power supply. Basically this is a protection capacitors or filter capacitors that remove the interference in the circuit. We find always this kind of capacitor in parallel, means it connects the line with the neutral in order to remove and to eliminate the high frequencies. Okay, so to test this kind of capacitors, you should always use, as you can see, this mode, the continuity mode in the multimeter. And this capacitor should never be shorted. Okay, if the capacitor is shorted, means bad. Okay, so let's check. So we can just test these two terminals. Let's put this one and this one. As you can see, now continuity means this is a good one. Okay, let's check this one also. So now continuity means also this one is good. Here basically I have an LED. As you can see, many of my followers ask me how to test this LED. Basically, if you focus here, inside this LED or light emitting diode, we have two parts, this big metal part and this also. So basically this is the cathode. The big one is the cathode and this one is the anode. So we should put here the red probe and here the negative probe. Okay, so let's check it. So the same working principle as the diode. So here I will put the red one and black one here. As you can see, I get a reading. So this is the anode and here we cut it. I get a reading in the multimeter. Do you see? So if I swap the probes, so as you can see, nothing in the multimeter. And do you see? The LED eliminated. Okay? Do you see? Here the LED means this is a good LED. Okay? Let's get right now and to check the transformer. So basically the transformer contains many inductors inside it, as you can see. So, and for the transformer we have always the primary winding and the secondary winding. Okay? Two parts. Okay? So to check basically the transformer, we should just check using the same mode here, the continuity of this coil. So this is the first one. As you can see, we get a low resistance and a buzzer, so this is good winding or coil. And this one, we get a reading, as you can see, low resistance. This is a good one. Let's check here also. So this should be the first one. So we don't get a reading here. So let's check this one also. We don't get a reading. So maybe the inductor is here. Let's check this too. As you can see, low resistance in the multimeter, as you can see, means here these two are one inductor, and these two here should be another, as you can see. Okay, so we have the first coil, the second, and here we have the two others. This transformer basically is a good transformer. So let's check this one also. Okay, so here we have 4 terminals, and here basically we have 5. We're gonna see. So let's check this inductor. Let's check this one also. So let's check here. Okay. So here we have the first inductor, as you can see. This and this, and this should be the second one, as you can see in the multimeter. Okay. So let's see here also. This is another inductor. Okay, this too. And this is another inductor. So basically these 3 terminals belong to the same inductor, as you can see. Here we have, as you can see in the multimeter, we have low resistance and buzzer, and also this and this. Also this one and this one. Okay, so here we have inductor with 2 terminals, and here inductor with 3 terminals. Okay, so this one also is good. So I will add for you another component. Let's test here this component. This is the Zener diode, as you can see, this one. So basically the Zener diode also contains cathode and anode, as you can see. So this is the symbol for Zener diode, and here we have the symbol for normal diode. Okay, so to check the Zener diode, you should do the same. Just put the black probe here in the cathode and the red probe into anode. So let's check. Always using the diode option. Okay, so here I should put the black probe here and the red probe here. I get already in the multimeter, as you can see. If I swap the probes, nothing in the multimeter. Let's check this one also. Here I get a reading. If I swap the probes, nothing in the multimeter. So let's check this one also. So reading in the multimeter, this one also. Reading in the multimeter. Okay. So now let's see some real MOSFETs in real motherboards. As you can see here, we have 4 MOSFETs that we're gonna check step by step. So as you can see, we have here U2. U stands for a MOSFET or an IC in a motherboard. So as you can see here, we have the dot here. This dot, this white dot means this is the pin number 1, as you can see, 2, 3, and so on. Okay, basically here we have source. These 3 pins are source, as you can see. Here we have gates and over here we have drain. 4 pins are for drain. So now let's check this MOSFET using the same working principle. Let's check the source. These 3 pins should be connected together. As you can see here in the multimeter, we have a low resistance in the multimeter. 3 pins are connected together. These 3 pins are source. These 4 pins also should be connected together. As you can see in the schematic, this is the drain. As you can see, we get a low resistance in the multimeter. Means the 4 pins are connected together. As you can see. Here also the same working principle. We have a dot here, means this is the pin number 1, 2, 3, 4, and so on. Here we have the drain. Okay, the same also for the third MOSFET. Okay, always the white dot means the pin number 1. So if we check between source and drain, as you can see, we get a reading here in the multimeter, means this is a good MOSFET. This is basically NPN channel MOSFET. When you put the red probe in the source and the black probe in the drain and you get a reading, means you have NPN channel MOSFET. And when we switch the probes, as you can see, we don't get anything in the multimeter. So between source and gate, you should not get nothing in the multimeter. Also between gate and drain, nothing in the multimeter. Means the MOSFET is a good MOSFET. You will get just a reading between source and drain, in accordance with the type of the MOSFET. If the MOSFET is NPN MOSFET, when you put the red probe in the source and the black probe in the drain, you will get a reading. So let's check the third MOSFET. As you can see here, between source and drain, we get a reading. Means this is another NPN channel MOSFET. Okay, this is NPN channel MOSFET. Basically, this is a good MOSFET. Between gate and source, nothing in the multimeter. Gate and drain, nothing in the multimeter. Means this is a good MOSFET. Basically, a bad MOSFET is a MOSFET that get a low resistance in the multimeter. Let's check these 2 MOSFETs also. Basically here, this is a 4P MOSFET or a 3P MOSFET. So here we have gates, as you can see, drain. Here also we have drain. Basically these 2 terminals are connected together. And here we have source. We're gonna use the same working principle to check this MOSFET. So here, as you can see, this is drain. We have a low resistance in the multimeter. It means these 2 terminals are connected together. So let's check right now between source and drain. We get a reading. So let's check this MOSFET also using the same working principle. Always the 2 terminals in the middle are connected together. So between source and drain, we get a reading. Means this is a PNP channel MOSFET. Because if we switch the probes, nothing in the multimeter. So basically this is a good MOSFET. So remember, a bad MOSFET is a MOSFET that gives a low resistance or a buzzer when you test it. Here basically this kind of MOSFETs, we find it in the computer or old laptop motherboard. So here, as you can see, using the same working principle, so the 2 terminals in the middle are the drain, as you can see. We have a low resistance in the multimeter, means the 2 terminals are connected together. So let's check between source and drain. We get a reading, means this MOSFET is a good MOSFET. Okay? So let's switch the probes. We should not get anything in the multimeter, means this is a good MOSFET. So let's check this MOSFET also. Here we have the gate, drain, as you can see, and source. So let's check between source and drain. Here we have nothing in the multimeter. If we switch the probe, we get a reading, means this is NPN channel MOSFET because we put the red probe in the source and the black probe in the drain. So let's check this MOSFET. Also, basically, this is a flat MOSFET, 8-pin flat MOSFETs. We find this kind of MOSFETs near to the processor. So let's check it using the same working principle. Here we have a dot, means this is the pin number 1, 2, 3, and so on. This is the source. These 3 pins are connected together. Here we have the gate, and over here we have drain, 4 pins connected together. So let's check right now the drain. All pins, as you can see, are connected together. Here we have 4 pins connected together. As you can see in the multimeter, we get a low resistance. So between source and drain, we get a low resistance. So when we check between source and drain, we get a low resistance. Why? Because the processor is connected to the motherboard. If we remove the processor, we will get a high resistance. So it's not a short circuit. So let's remove the processor right now and check again that MOSFET. Now we remove the processor. Let's check right now between source and drain. As you can see, we get a high resistance. So this is a good MOSFET. It's not a shorted MOSFET. Also for this, we get a high resistance. But if we connect back the processor, we will get a low resistance. Means the resistance is for the processor, not for the MOSFET. So here we switch the probes, we don't get anything. So let's put back the processor and then check the MOSFET. So now the processor is mounted or connected to motherboard. So let's check between source and drain. We have here a low resistance. This is not a short. This is basically the resistance for the CPU. So as you can see, we have 0.23. This is a low resistance, but this resistance is for the CPU. So let's check it out. This MOSFET also, basically here, this is a small MOSFET with 3 terminals. As you can see, using the same working principle, we gonna check between source and drain. So the rule is you should get a reading between source and drain. If you get a low resistance or a buzzer, means the MOSFET is bad, exactly the same as the transistor. So let's check. Here between source and drain, we get here, as you can see, a reading in the multimeter, means this MOSFET is good. Between gate, drain, and gate and source, you should not get anything, as you can see. So let's check the second MOSFET. So here, between drain and source, we get a reading, as you can see, in the multimeter. If we swap the probes, we will not get anything, as you can see here in the multimeter. Hi everyone, so in this video I'm going to show you how to test Triac using the multimeter. As you can see here, I have a Triac, as you can see. Of course, it has 3 pins or 3 terminals, as you can see. So this is the pin number 1, pin number 2, and pin number 3. So here we have the reference or the part number for the Triac. We have BTA12600B. If you have a bad Triac with this reference, you should replace it with the same reference, of course. Here, this part is used to connect the Triac with the heatsink because the Triac gets hot when working. So basically, before going and testing the Triac using the multimeter, I'm going first to show you all about the Triac symbols. Okay, as you can see, this is the symbol of the Triac. It contains 2 diodes, as you can see, and of course 3 terminals. So the anode, as you can see, 1, the anode 2, and the gate. Of course, you can find anode 2, or T2, or M2, or MT2. All these names means the same thing, okay? So here, as you can see, you can find also the symbol for the triac. But basically, this symbol is a clear symbol. The diodes are clear. Here, the same symbol, as you can see. This is also a symbol for the triac, as you can see. Anyway, it contains 3 pins. So I'm going now to show you a real circuit in order to understand the working principle of the triac and how it works. This is an easy circuit that I'm going to explain to you. So basically, this is the triac. As you can see, it contains 3 terminals, okay? And here we have a lamp, okay? And here this is a DC voltage, 12 volt DC voltage. And over here, the gate is connected to a switch and to a control signal. We have 1.5 volt DC. This is a control signal. So now the switch is open, the lamp is off, okay? You know why? Because the triac until now is not activated. So the current, as you can see, is not passed through the triac because the triac is not activated. So that's why the lamp is off. But if we close the switch, as you can see, now the control voltage 1.5 volt DC will pass through the switch and then to the gate. And then now the triac will be activated. Okay? So the triac has the same working principle basically as a transistor. Now the current will circulate through the circuit and will pass through the triac, as you can see, and then of course the lamp will be lit. Okay? So basically the triac has about 80% the same working principle as a transistor or a MOSFET. But in terms of testing, it's not like a transistor. The triac testing is a very special testing. So now let's test the triac using the multimeter, okay? So we're gonna of course select the continuity option in the multimeter, as you can see. Now a good triac is a triac that shows 0.70 drop voltage between gate and anode 1. Okay, between the anode 1 and the gate, you should get about 0.70 in the multimeter. So let's check this triac. Okay, so between pin number 1 and pin number 3 or anode 1, we should get about 0.70 in the multimeter. Of course, if you get 0.60 or 0.50, no problem, the same. So let's check. We have about 0.68, means this is a good triac. Even if we switch the probes, we should get the same value as we get before. So let's check. We have 0.68. This is a good triac. Okay? So depending on the type of the triac you are testing, you can get 0.50 or even 0.40, no problem. So always between the gate and the anode 1 or between the pin number 1 and the pin number 3, you should get a reading about 0.70, 0.60, 0.50, no problem. But between other pins, you should not get anything in the multimeter, as you can see. Nothing between pin 3 and pin 2, as you can see. The only pins that shows the reading is pin number 1 and pin number 3, as you can see, or the gate with the anode 1. And if you get any short while testing the triac, means the triac is bad. Now, as you can see, every triac should be connected to its heatsink because it releases heat. It gets very hot. That's why you should always pay attention. If you have a triac with a heatsink, you should always use the heatsink. If you ignore the heatsink, the triac can be damaged because it gets hot. Okay? As you can see, we have the triac now is connected to the heatsink, as you can see. Let's test some transistors. NPN transistors and PNP transistors. So as you can see here in this motherboard, we have many transistors. Basically, the reference of transistor is Q. So here we have the base, emitter, and collector. Okay? So base, emitter, collector. Okay, so basically here for NPN transistor you will get a reading when you place the red probe of the multimeter in the base and the black probe once in the collector and once in emitter. And for PNP transistor you will get a reading when you place the black probe of the multimeter in the base and the red probe once in collector and once in emitter. So let's select the buzzer option or the diode option in the multimeter and let's get started. So let's check this transistor. So we're gonna put the black probe in the base and the red probe in the emitter. We get a reading. So base collector, we get a reading. Means this is a good transistor. Okay, we get a reading between base collector and base emitter. So this is basically a PNP transistor. Okay, PNP transistor. Okay, because we move the positive terminal. So here we have a reading, and here also we have a reading. Okay, so if we switch the probes, we should not get any reading because this is a PNP transistor. So let's see here. Between base emitter, we have nothing. Base collector, we have nothing in the multimeter. Means this is a good transistor, and of course this is a PNP transistor. So let's say right now the second transistor, basically this transistor is NPN transistor. So let's put the red probe in the base and the black probe once in the collector and once in the emitter. We have a reading here between base emitter, and here we have a reading between base collector. Means this is a good transistor, and of course this is NPN transistor. As you can see, we have negative, positive here in the base, and negative. Okay, so this is NPN transistor because we get reading when we move the black probe of the multimeter. Okay. So if we switch the probes, we should not get any reading. So let's check. Here between base emitter, we have nothing in the multimeter. Base collector, nothing in the multimeter. Okay, so this is basically a good transistor. So let's check other types of transistor. Here basically this is a transistor with 4 terminals. Okay, but the 2 terminals in the middle are connected together. Okay, here we have base, as you can see, collector. This also is connected. These 2 pins are connected together, and emitter. Okay, so base, collector, and emitter. So let's check first these 2 terminals. So we get in the multimeter a low resistance, about 0 ohm. Means these 2 terminals are connected together. Let's check this also. We have a low resistance in the multimeter. So these 2 terminals are connected together. So right now we gotta check these 2 transistors. So let's put here between base, collector, we get a reading. So base, emitter, we get a reading. So this is a good transistor. If you get any buzzer or a low resistance in the multimeter, means the transistor is bad. So if we switch the probes, nothing in the multimeter. Okay, so this is a good transistor. So let's check the second one. So here we have base, as you can see, collector and emitter. So let's put the black probe in the base and the red probe once in emitter and once in collector. So we get a reading here and also base emitter, we get a reading, means basically this is a good transistor. Okay, so let's check this kind of transistor also. Basically this is SMD transistor, or surface mount technology device transistors. We find this kind of transistor in computer motherboards. So basically here we have 4 terminals. The 2 terminals in the middle are the collector. Okay, the reference for the transistor is Q. So here we have base, as you can see, collector. Here also we have collector, okay, because connected together, and here we have emitter. So let's check using the same working principle. First, let's check these 2 terminals. Here we have a low resistance in the multimeter, means the 2 terminals are connected together. So right now we gonna check this transistor using the same working principle. Here we have a reading between base and collector, and between base and emitter we have a reading, means this is a PNP transistor because we move the read probe of the multimeter. When you move the read probe of the multimeter, means you have a PNP transistor, and when you move the black probe of the multimeter, means you have an NPN transistor. Hi, in this video I'm going to show you how to test the DC motors and the winding inside it. So the DC motor contains a rotor and a stator. Here this is its terminals, plus terminal and minus or negative terminal. So this is the plus or the positive terminal, and here we have the negative terminal. The same for this. Positive terminal, negative terminal. This part, read part, means positive. So this is basically the winding inside the motor, or this is the stator. Okay, inside this hole we have the rotor. Okay, so of course I'm going to show you how to test this winding using the multimeter. Of course, for each motor or winding you will find an integrated circuit, as you can see, that controls the speed of the rotor. So we're gonna use, of course, the multimeter. We're gonna select the continuity option to test the winding or the inductors. So let's test these 2 motors using the multimeter, of course. So first of all, you should locate the positive terminal and the negative terminal, and as you can see we have a low resistance, means the winding inside the motor is good. So let's check this motor also. Basically we check the winding inside it. We should get a low resistance, about 0 ohm. As you can see we have 0 ohm, means this motor also is a good motor. Here basically this is the winding inside the motor. We're gonna now check this winding. So basically this is just one winding. It's not 4 inductors here, just one. It has just 2 terminals, as you can see, V1 and V2. So if you focus here, you can see the wires. Here we have 2 wires, okay? The terminals of the whole winding, okay? So this is just one winding that we gonna check. As you can see here, we have wires, 2 wires, okay? So this is just one winding. So let's check it. We should get a low resistance in the multimeter. If you get open line or just one in the multimeter, means the winding is scattered. So let's check. We should get a low resistance, as you can see in the multimeter. This is basically about 0 ohm, 008. This is good. So now I'm going to power this motor. So of course using the power supply, and check the rotation of the motor. So of course you should always respect the positive terminal and the negative terminal. So the first thing is to determine positive and negative terminals. So we're gonna use, of course, this adapter, as you can see. So this is AC to DC adapter. This is, of course, 5 volt DC output, okay, and 150 milliamps. So I'm going to use this adapter. This is a normal adapter to check the motors. So let's check this motor. So here we have 5 volt in these two cables. So the positive to positive terminal and the negative to negative one. So let's check. The motor should be a rotation, as you can see. So if you change the cables, you put the positive in the negative terminal and the negative in the positive terminal, the direction of the rotation of the motor will be changed. Okay? So basically, this is the stator. Okay, so a stator is the fixed component of the motor, and the rotor is the rotating part. As you can see, this is the rotor, the rotating part of the motor. How to test the Schottky diodes? So we find the normal diodes in the primary stage of every flyback power supply and the Schottky diodes in the secondary stage of any flyback switch mode power supply. Of course, as you can see here, this is Schottky diodes with two diodes connected together. Here also we have another kind of Schottky diodes with just two leads or two terminals, as you can see. And over here we have a Schottky diode with three terminals, as you can see, connected to the motherboard. And this is its heatsink, because this kind of diodes gets hot. That's why we have the heatsink here. Always you should differentiate between normal diodes like those diodes as you can see here and Schottky diodes. Okay, so here this is just a general purpose diodes or a standard diodes, and this is the Schottky diode. Okay, so I'm going to show you the differences between standard diodes and Schottky diodes. So we're gonna use the multimeter to test these diodes, and we're gonna select the diode option in the multimeter. So let's begin first with testing a normal diodes or a standard diodes in order to see the difference between both. Here we have a 500 drop voltage. Okay, so let's check the other diode. So as you can see, we have about 500. The drop voltage or the reading is about 500 for standard diodes. But for the Schottky diode, as you can see, let's check the drop voltage. As you can see, we have a low drop voltage. So the Schottky diodes always give a low drop voltage. Okay? That's why you should never replace a bad Schottky diode with a normal diode or a standard diode. Never. Because if you change or replace a bad Schottky diode with a standard or a general purpose diode, it will be damaged immediately. Because the Schottky diode is a fast switching diode with a low drop voltage. Okay? So here, this is another flyback motherboard, as you can see. This is the primary stage, as you can see, where we have the fuse and electromagnetic interference. So those diodes are normal diodes, and over here we have Schottky diodes. As you can see, we have two Schottky diodes, one with two leads, as you can see, and the other mounted to the heatsink with three leads, as you can see. So let's check these normal diodes also. We have about 500, the reading or the drop voltage. Let's check the second one, the same, about 500. This is a high drop voltage basically, but if we check this one, this is the Schottky diode with three terminals or three leads. So we should find a low drop voltage. Here we have its terminals, as you can see in the back of the motherboard. Okay, basically it contains two diodes inside it, so we're gonna check two diodes. The same, the first diode we have 128. The second diode about 128. So this is a low drop voltage. So this is a good Schottky diode. This is the Schottky diode shape. It contains two diodes connected together with their cathodes, as you can see. So always when test the Schottky diode, you should get a low drop voltage. If you get any continuity or buzzer, means the diode is damaged. Here we have the second diode. This is a good Schottky diode. This is how you can test it. If you get any buzzer or any continuity, means failed, automatically you should change it. Let's check this also. We have another one with the same working principle. Basically, it contains two diodes inside it. Here we have its reference or part number. This is MBR 2010. So let's check it again using the same working principle. The first diode we get about 130. Good. Low drop voltage. We have 135. A low drop voltage. This is another good Schottky diode. Okay, so this is how you can check this kind of diodes. Here we have 7812, means this is a 12 volt output regulator. Okay, and of course we have three leads. This is the input. Here we have the ground, and here we have the output. Okay, so I'm going to show you how to test this kind of voltage regulator using just the multimeter without feeding it with the power in its input. So as you can see here, this is one of the most used voltage regulators in the electronics, 78XX series. Okay, so by definition, the 78XX series is a linear voltage regulator with an input voltage of 14 to 35 volt DC in general, and its output can vary from 5 volt to 15 volt depending on the type of regulator. So of course, as you can see here, this kind of voltage regulator contains three terminals or three leads. So the first one in the left is the input, the middle one is the ground, and over here this is the output. Okay, so the output vary depending on the type of the regulator. For example, for this kind of voltage regulator with the reference 7805, the output will be 5 volt. For 7806 will be 6 volt. And for voltage regulator 7808, the output voltage will be 8 volt, and so on. Okay? So always the two last digit in the reference regulator means the output voltage. Okay? So as you can see here, for example, we have 7805 volt voltage regulator. The input voltage is between 14 and 35 volt DC, and here we have the output is 5 volt. Here we have 78 and 12, the output is 12 volt. In general, this is the rule, 78XX. So always the two last digit means the output voltage. Okay? This is a real voltage regulator, as you can see, okay, with three terminals. So I'm going to show you how to test this kind of voltage regulator using just the multimeter without feeding it with the power in its input. So of course we're gonna use the multimeter and we're gonna select the continuity option, and here we're gonna check between the input and the ground. We should not get any continuity or buzzer, and also between ground and output, as you can see, nothing, no buzzer, no continuity in the multimeter, means this is a good voltage regulator. Of course, you should check also between the ground and the output. We get a reading, this is good. If you get a reading or no reading, this is no matter, this is not a problem. But if you get a continuity, means the voltage regulator is shorted. Okay? But to be sure, of course, you can feed in it with the power, with the appropriate power in its input, and measure the output. So if you check the continuity between its pins and you didn't find any short, means the voltage regulator is about 90% a good voltage regulator. But if you want to be sure 100%, you have to feed the power voltage in its input and measure the output. For example, for this kind of voltage regulator, you should find 5 volt in the output voltage regulator. How to test optocouplers or optoisolator using the multimeter. So I'm going to show you how to test a 4-pin optocoupler and a 5-pin or 6-pin optocoupler. So basically this is the circuit diagram of the 4-pin optocoupler. Here we have a 4-pin optocoupler, as you can see in the motherboard. It contains 4 pins, as you can see. Okay. So this is the pin number 1, always marked with a white mark or a hole here. Here also we have another type of optocoupler, as you can see, with 4 pins. This is of course the pin number 1, okay? Pin number 2, 3, and 4. So this is the circuit diagram for 6-pin optocoupler. As you can see, it contains 6 pins, of course. Here we have a real optocoupler IC, as you can see, with 6 pins. This is its reference, okay? So let's begin with 4-pin optocoupler or optoisolator. As you can see, we have pin number 1, number 2, number 3, and number 4. So basically, this optocoupler contains 2 components inside it, an infrared diode and a phototransistor. So pin number 1 connected to the anode and pin number 2 connected to the cathode of the diode. And over here, as you can see, the pin number 4 connected to collector. Here we have collector, and here we have emitter. So this is the same for all optocouplers with 4 pins. The same schematic. Always pin number 1 connected to anode, pin number 2 to cathode, pin number 4 to collector, and pin number 3 to emitter. So let's test the 4-pin optocoupler. So of course, between pin number 1 and pin 2 of the optocoupler, we have a diode. So if we test between pin number 1 and pin number 2, we should get a drop voltage about 1000, okay? And between pin number 3 and pin number 4, of course, we should not get anything in the multimeter, because always between collector and emitter, for every transistor, if you test it, you will not get anything. So of course, we're gonna use the multimeter and we're going to select the diode option because we're going to test the diodes, okay? So let's test this optocoupler, as you can see. So always you should first locate the first pin, okay? Pin number 1. So pin number 1 connected to anode and pin number 2 connected to cathode. And of course, pin number 3 and pin number 4 connected to the phototransistor, to the collector and emitter of the phototransistor. So let's check right now this optocoupler using the multimeter. So let's put the red probe in the first pin, the anode, and the black probe, of course, in the cathode. We should get about 1000, a drop voltage about 1000, as you can see. In the multimeter, we have 1100, means this diode is a good diode. So if we swap the probes of the multimeter, we should not get anything in the multimeter, okay? So let's check. As you can see, we get nothing in the multimeter. Means the diode inside the optoisolator is a good diode. Now let's check the phototransistor. Of course, the pin number 3 and pin number 4 connected to the phototransistor. We should not get anything in the multimeter. As you can see, nothing means the phototransistor is not shorted, is a good transistor. Means the whole optocoupler is a good optocoupler. So if you get any short between the optocoupler terminals, means the optocoupler is bad. So if you get a short between the pin number 1 and pin number 2, or pin number 4 and pin number 3 for the transistor, means the optocoupler is shorted. You should replace it with another optocoupler with the same reference. So let's check now this optocoupler. As you can see, using the same working principle, of course, we should always locate the pin number 1. So let's put the red probe of the multimeter in pin number 1 or anode and the black probe in the cathode. We should get a reading about 1000, as you can see, 1100. So this diode is a good diode inside the optocoupler. So if we swap, of course, the probes, we should not get anything in the multimeter. As you can see, nothing. Means this diode is a good diode. Now let's check the phototransistor in the other side of the optocoupler. Of course, we should not get anything between pin number 3 and pin number 4. Because if you check any transistor between collector and emitter, you will find an open circuit. So here we have 1 in the multimeter. Means the transistor is good. Means the whole opto-isolator is good. Okay? So this optocoupler is a good optocoupler. So of course, I want to add that if you find any short between optocoupler pins, means the optocoupler is shorted. So you should never find a short between pin number 1 and pin number 2 and pin number 3 and pin number 4. Now we're gonna see how to test the 6-pin optocoupler. So basically this is the circuit diagram, of course, of 6-pin optocoupler. Okay, here we have the diode and the phototransistor. As you can see, the same as the optocoupler with 4 pins. So the pin number 1 is connected to anode and pin number 2 connected to cathode of the diode. Exactly the same as this optocoupler. Okay, always pin number 1 and pin number 2 connected to the diode or to infrared diode. So here pin number 4 and pin number 5 connected to the phototransistor. So pin number 4 connected to emitter and pin number 5 connected to collector. And of course the pin number 3 and pin number 6 are not used. No connection. In C means no connection. And sometimes in some optocouplers, you can find that the pin number 6 is connected to the base. Okay? So sometimes the pin number 6 of a 6-pin optocoupler is connected to the base. But you can discard it. It's not important. Important thing is the diode and the phototransistor. Okay? So here, as you can see, we have the optocoupler that we're gonna check. Its reference is CNY17F-2, as you can see. Always this age means the pin number 1, as you can see. This is pin number 1, 2, 3, 4, 5, and 6. Okay? So always the pin number 1 and pin number 2 connected to the diode. This is connected to anode, the pin number 1, and the pin number 2 connected to the cathode of the diode. So we're gonna check this optocoupler, and of course we're gonna check the pin number 1 and pin number 2 where we have the diode. So we should get a reading about 1000 drop voltage, the same as the optocoupler with 4 pins. So let's check. We're gonna put the red probe in the pin number 1 and the black probe, as you can see, in pin number 2. We should get a reading, as you can see, about 1150. This is a good diode, basically. So if we swap the probes, we should not get anything in the multimeter. So we're gonna put the black probe in the first pin and the red probe in the second pin. Here we don't get anything in the multimeter, means the diode inside the optocoupler is a good diode. Now let's check the other side where we have the phototransistor. So basically the phototransistor, we're gonna check between collector and emitter. So pin number 4 and pin number 5, as we have in the schematic. We will not find anything, no reading in the multimeter, means the phototransistor is serviceable, is a good phototransistor. And of course, this means that the optocoupler is a good optocoupler. Okay, so you can look for the datasheet for any optocoupler you want. For example, let's search for the datasheet of this optocoupler, a 6-pin optocoupler, CNY17F-2. So you can just pick the first result. As you can see, we have a datasheet. Okay, and here, of course, this is all datasheet website where we have datasheets for integrated circuits. Here we have, as you can see, the 6-pin optocoupler for power supplies. Here we have the same part number or reference, as you can see, CNY17F-2. So you can just click this PDF file to download it. And then, as you can see here, you can click download over here, click the reference, and here we go. We have the file, as you can see. So this is the file, the 6-pin DIP optocoupler for power supply applications. So of course, to download this PDF file, you can just click here. Here we have description, features, applications. As you can see, we have power supply regulators. It can be used for digital logic inputs, microprocessor inputs, and so on. And this is the schematic, as you can see, the same schematic as we have seen before. The pin number 1 connected to anode, the pin number 2 connected to cathode, as you can see. Pin number 3 and pin number 6 are not used, and of course pin number 4 and 5 connected to the phototransistor. Okay? And of course you can read other things like characteristics, the temperature, the voltage, the maximum voltage and minimum voltage, and so on. How to test the relays, okay? So as you can see, the relay contains 4 terminals. So 2 terminals for inductor and 2 other terminals for switch. Here this terminal is not used. Just 4 terminals. Here we have the inductor, as you can see. Here we have the inductor, and this is the switch. Okay, these 2 terminals for switch. For this also we have inductor here, as you can see, and here we have the switch. Okay, here we have nothing, and here this is not used. Basically, this is the circuit diagram of the relay. As you can see, we have the inductor here. This is the inductor terminals. Okay, as you can see here, this is the inductor in the relay, these 2 terminals. And here we have the switch, okay? It contains 2 terminals. So here, this is the switch terminals, as you can see. So here, this is the input voltage. It can be 12 volt, 24 volt, or even 28 volt in accordance with the type of the relay. So when the voltage is applied to the inductor, the current will pass through inductors, as you can see, and then an electromagnetic field will be created. And then the pole will be pulled, and then the switch will be closed. Okay? As you can see. And then the main power will pass through the switch to the load. For example, a motor. So the motor will run. So let's see the relay characteristics. Basically, as you can see, this is the characteristics of the relay. Here, this is the relay model or reference. If you have a damaged relay, you should replace it with another relay with the same reference. Here, this is the manufacturer company. and here this is the main voltage that can be passed through the switch. It can be 10 amps, 240 volt EC, or 10 amps, 24 volt DC. And this is the working voltage, okay? This is the working voltage that can be applied to the inductor. Here I'm going to use this adapter to test the relay. This is basically a 12 volt adapter. So a 12 volt DC adapter, I'm going to use it to show you how to test the relay. So here we have the inductor, as you can see, and here we have the switch. So let's apply right now. As you can see, the voltage, you hear a click, means the relay is good, okay? So let's use the multimeter to check the switch. So let's check now. The switch is opened, of course. We have nothing in the multimeter. But if we apply the voltage to the inductor, the switch will be closed automatically. So now we apply a voltage, a 12 volt DC voltage to the inductor. Now the switch is closed. If we check now using the multimeter, we will get a low resistance. So here we apply a 12 volt to this inductor, as you can see, okay? And of course, the switch now is closed or energized. So if we check now using the multimeter, we will get a 0 ohm in the multimeter. As you can see, we have 0 ohm in the multimeter. Means this relay is a good relay. So if we remove one terminal, now we have 0 volt in the inductor. The switch now is opened. We will get nothing in the multimeter, as you can see, because the switch is open. Okay? So basically, this is the working principle of the relay. So as you can see here, the relay contains an inductor and a switch. Okay? So by default, the switch is opened. Okay? So if you check the switch using the multimeter, when you don't apply any voltage, you will get up loud in the multimeter. Okay? But if you apply a voltage, for example 12 volt DC to the inductor, okay, the switch will be energized, will be closed, and then you will get in the multimeter 0 ohm, or you will hear a buzzer. So let's do an experiment. We connect the probes of the multimeter to the switch terminals, as you can see, and we will apply the voltage here to the inductor terminals, and we're gonna see what will be happen. So let's apply the 12 volt to the inductor, and of course let's see the multimeter, what we will get in the multimeter. As you can see, we hear a click and we get a low resistance. We hear a click and we get a low resistance in the multimeter. And of course, here the switch is opened and closed, as you can see.
Hi, in this video I'm going to teach you step by step using the multimeter how to test power MOSFET, transistors, voltage regulators, pulse width modulation IC or power management ICs, optocouplers or opto-isolators, bridge rectifiers, Schottky diodes, and much more. And of course, I'm going to teach you how to identify the type of these ICs. Because this one, for example, is it a transistor, a MOSFET, a voltage regulator,
a Schottky diode or what? Based on what we can identify whether the component is a transistor, MOSFET, etc. So this is a free course where you will learn everything about how to test electronic component, especially the component with 3, 4, 5 and 6 terminals. So please go with me step by step and follow with me until the end of this video, and I will guarantee for you that you will be a pro on electronic component testing. So let's get started. But first, don't forget to subscribe, share the video with other people like you, and like the video, because your engagement really motivates me to create more and more videos for you. Thank you very much. And for anyone who want to join me in the Patreon page, you are very welcome. So let's get started. So here we have basically main component, as you can see here. We have MOSFET, transistor, etc. So this one, for example, and this one, as you can see, they have the same shape and the same number of terminals. 3 terminals, 3 terminals. Okay? This one also has 3 terminals. This one also has 3 terminals, as you can see. So how can I identify these ICs? This is MOSFET, this is transistor, this is voltage regulator, and this is an IC, a pulse width modulation IC that is used in switch mode power supply. So I cannot begin and test the component without knowing the type of component. For example, this is voltage regulator. I cannot test it using the same working principle as transistor. Wrong. Okay? So the first step is to know about the type of the component. Okay, so we can know about the type of component using basically 2 methods. By experience, for example, for me, when I say this number, as you can see over here, so K2611, the component that began with this number, for me, based on my experience, is always MOSFETs. Okay? And others, for example, that began with D24, as you can see, like this one, is transistor, not MOSFET. Okay? So based on reference, for example, this type of, as you can see, component, as you can see over here, this is bridge rectifier, because here, as you can see, we have plus, minus, and we have EC symbol here. So this is simple. This is bridge rectifier. Okay? So, and other component like this, where you find 2 diodes, as you can see, like this one. Where you find 2 diodes connected together like this one. So this is a Schottky diode or a rectifier symbol. Okay? So, for example, here I have many components here. Okay, how can I see, I know whether this is transistor or MOSFET, etc. So based on two methods. So the first one is by experience. You know, using your experience, the references. The second one is to use the internet. Simple. I will give you a website, a very important website that I use in a daily basis, that provide me with all information about any component I want. So based on this simple website, the type of this IC. If you don't have enough experience on identifying the type of IC, you have to use this website. Basically, there is many websites, but for me, I prefer this website. For example, this is MOSFET. Okay, so let's confirm whether this one is MOSFET or not. We have K2611. I will show you this website in the computer and how you can find the type of the IC based on its reference. After that, I will use the multimeter to test all these components one by one. Okay, so let's go to the computer. So here, as you can see, let's go to Google, for example, and just as you can see over here, we have K2611. So let's write K2611, okay, and just press enter. Okay, let's pick the first result. As you can see here, basically this is the website over here. We have alldatasheet.com. This is a very important website that I use in a daily basis in order to find the type of component. So here, as you can see, we have K2611. So I can just go here. As you can see over here, we have K2611. So this is a silicon N-channel MOSFET. Okay, so I confirm that this component is a MOSFET. Okay, and I know here that this is N-channel MOSFET, not P-channel MOSFET. So if I want to download, for example, the datasheet for this MOSFET, I can just go here. This is the PDF file where we have, as you can see, 7 pages. So let's click over here and then go here. We have download and click K, the part number of the component. And as you can see, here we go. Okay, so we have the MOSFET. So I confirm that this component is MOSFET. Okay, we have MOSFET, we have gate, source, drain, and of course you can read about it, its characteristics, and of course the function, block diagram, etc. Okay, if you want to download it, you can just click over here in this icon and go here. As you can see, we have a security code for 21290 and press download, and as you can see, here we go, the file is downloaded, and then you can open it and read. As you can see, we have the file over here. So you can use this working principle for all components. So now here for this component, this is the MOSFET. So once I identify that this component is the MOSFET, then I can test it using the multimeter. Okay, so this is the MOSFET. I can test it using the multimeter and using the right method to test the MOSFET. So because this is the MOSFET, so I have here, as you can see, so this is gate. Okay, here we have drain and here we have source. If we go to the file, for example, so I upload the file. So let's go and check the file over here. So here we have gate, as you can see here, drain, source. Okay, so gate, drain, source. So now I will use the multimeter to check whether this MOSFET is good or not. So of course I will choose the diode option, as you can see. Okay, I will choose the diode option and then press the power button. So let's check. First thing to do is to connect between these two pins and these two pins in order to discharge the MOSFET. So let's test this MOSFET right now. So we know that this MOSFET is N-channel MOSFET. So the diode, as you can see here, is between source and drain, and the anode connected to the source, the cathode connected to the drain. Okay, so I will find a reading when I put the red probe in the source and the black probe in the drain, because this is N-channel MOSFET. So let's put the red probe in the source, as you can see here, and the black probe in the drain. I should get a reading about 400, 500, 600. As you can see in the multimeter, I get the reading because this is N-channel MOSFET. But if I swap the probes, as you can see, I will not get anything in the multimeter. As you can see, nothing in the multimeter. Also, between source and gate, nothing. Between drain and gate, nothing, as you can see. So the only reading is between source and drain, and when I put the red probe here and the black probe here, because this is N-channel MOSFET. Okay, so this is it for this one. Let's see another one. This time we're gonna see a transistor. Okay, so let's put the MOSFET here. Okay, So here we have transistors. Basically for me, I know based on the part number, I know whether this is a transistor or voltage regulator or MOSFET, no problem. But for you, the first time, you should use the part number. So what is the part number here? We have D2499, as you can see over here, D2499. So let's go to our website and put this part number and check whether this is transistor or not. So here we have the part number. Okay, by the way, using this website you can search using the part number, using the description or the marking. For example, the description, if you don't know the part number or if you cannot read the part number. For example, if you cannot read the part number is missing here, you can use the description. For example, use here N-channel MOSFET. Okay, especially for example 30 volts MOSFET, N-channel MOSFET or N-channel 30 volts MOSFET. Okay, and then the website will give me all MOSFETs that has the voltage, the maximum voltage of 30 volt, okay, or 28 volt, etc. But the best way here is to use the part number. The best way is to use the part number. So let's go back to our component. Here we have D2499. So let's put D2499 and just hit enter. As you can see, here we go. So here we have D2499. So this is NPN. Okay, this is NPN, triple diffused meso type horizontal deflection output for color TV. Okay, we don't have here enough information. Okay, this is NPN means transistor, because for MOSFET we have N channel or P channel, and for transistor we have NPN or PNP. Okay, so let's see this file. Also we have silicon diffused power transistor. As you can see here, we have power transistor. So let's choose this one, because also this is transistor, NPN transistor. So here we have 5 pages. As you can see, we can just click over here in the PDF file and go here, download, and click again the part number, as you can see. So let's see, here we go. We have here, as you can see, Toshiba transistor, silicon NPN triple diffused meso type. So this is transistor, as you can see. Okay, here we have transistor, here we have base, collector, emitter. Okay, here the first pin base, collector, emitter. So this is transistor, not MOSFET, not voltage regulator. So this one is transistor. So now I can test it because I know that is transistor. So let's test it. Let's put it here. So here we have, as you can see, we have base. Okay, base. Okay, then collector, then emitter. Okay. So now let's use our multimeter, and of course using the same working principle we're gonna select the diode option, because the transistor contains diodes inside it, and just press the power button. And of course here we have base. Using the same working principle, let's discharge this MOSFET. Okay, because when you touch the base or the gate of the MOSFET with the red probe, you will get a wrong measurement. Okay, so always try to discharge the transistor and the MOSFET and then test it. And I know that this transistor, as you can see, is NPN. As you can see here, NPN transistor means, as you can see here, we have here P. So means, as you can see, NPN. So let's check. Oh, we got a buzzer. Here we got a reading. here we got a buzzer. So let's discharge again this MOSFET. Let's discharge it. Okay. Okay, so let's check again. So let's put the red probe here. We get a reading between base collector. So let's check between base emitter. We get a buzzer, a low resistance. Here we get a reading. Here we get a low resistance. So let's discharge again this MOSFET. Okay, so let's begin with the black probe here and the red probe here. We get a reading here. This is right reading here. We have a short circuit. Means this is a transistor, but unfortunately this transistor is a bad one. Okay, so this transistor is a bad transistor because we get a short circuit between base, as you can see, and emitter. Between base emitter we get a short circuit. Okay, we get a short circuit. So this one is a bad one. This is a good one. Okay, so I can't test these others, but I don't want to make a very long video, so let's pass. We gotta just test one component here, one here, etc. Okay, in order to avoid making a very long video. Okay, so here basically we have voltage regulators. But first, if I see this component, I cannot know whether this is a transistor or MOSFET. But if I look to the part number, for me, based, as I told you before, based on my experience, so for me, based on my experience, I know that 7812 CT is a voltage regulator. But let's check using our website. Okay, so here we have 78. Okay, so this is basically its part number is 7812 CT. So this is the part number. Okay, 7812 CT. So let's go to our website. Okay, here we have part number. Let's erase here and just write 7812 CT and press enter. Let's see. Here we have the same part number 7812 CT. We have 16 page for this part number, and this is 3 terminals positive fixed voltage regulator. As you can see, this is a voltage regulator. So if I want to check it or to test it using the multimeter, using the same method I used to check the transistor, wrong. Using the same method I used to check MOSFET, wrong. Why? Because this is voltage regulators. It doesn't have base collector emitter or gate drain and source. No, it has input, output and ground. Let's see the schematic. So here we have the PDF file, 16 page. So let's download it. Here we have download. Let's click again the part number, and here we go. We have, as you can see here, the PDF file. I can even download it. Let's click here, this icon, download. Okay, and go and enter the security code. So we have 61752 and just click download. As you can see here, so the file is downloaded. Okay, so let's open the file. Here we go. So here we have 3 terminal positive voltage regulator. As you can see here, if you focus here, so let's remove this. So as you can see, if you focus here, let's zoom a little bit. Okay, good. Here, this is basically voltage regulator. So we have here many part numbers for this voltage regulator or series. So we have the pin 1, 2, 3, not collector, emitter, and so on. No, 1, 2, 3. So the first pin is input, the second pin is ground, and of course the second pin here is connected to the side here. Means this pin, okay, in the middle is connected to this one. We can even check using the multimeter, as you can see. So this is ground. This pin here, as you can see here, in the schematic, pin 2 is ground. This also should be ground. So let's check using the multimeter. We should get a buzzer, as you can see. Low resistance in the multimeter. So this is ground. This and this are connected. So here we have, as you can see, input, ground, and over here we have output. Okay. You can find also this type of voltage regulator. Okay. So how can we test this kind of voltage regulator? So basically, to test voltage regulator using the multimeter, you should connect voltage regulator to the motherboard, or just give it the input voltage. For example, if the input voltage is 12 volt, give to this voltage regulator 12 volt here in the input. Okay, here. So here, this is, as you can see, here we have input. Okay, so here connected to the ground, and here we have output. Okay, let's assume that the output is 5 volt and the input is 12 volts. So to check whether this voltage regulator is serviceable or not, you should power it with 12 volt in its input and connect this one to the ground, and then you should use the multimeter to check whether this you get 5 volt or not. So once you feed it with 12 volt and you connect this terminal to the ground, then you can check these two terminals like this and get 5 volt in the multimeter. Okay, so this is how you can check the voltage regulator. But I will give you a trick that you can use to test whether the voltage regulator is serviceable, is good or not. So how? So here we have input, ground, and output. So I can just put the red probe in the ground. Okay, the red probe in the ground, and check between ground and input. As you can see, I get a value. This is not a diode, this is a value 557. So if I move the black probe to the output, I should get a double value. So let's check. As you can see, 1190. So here we have this value. Here I should get a double value. Means this is a good voltage regulator. Okay, sometimes you can find a short circuit, means a bad voltage regulator. Okay, so this is how you can check whether the voltage regulator is good or not using two methods. By applying the voltage 12 volt, for example, to the input and connecting the middle one to the ground, and you should check here or get 5 volt, or by checking using the multimeter, as I told you before, between ground and input you should find, for example, X reading, between ground and output X times 2. Okay, so this is for voltage regulator. This is basically the symbol, and then here a capacitor that is connected to the ground, an electrolytic capacitor like this one or like this one. This one we'll find it, as you can see, in switch mode power supplies like this, and this kind we'll find it in motherboards like this one, as you can see over here. Okay, so the inductor, its reference is L or PL. We have L. Do you see L15 for this inductor? For how to test inductor? Easy. You can just use the multimeter and you should select the continuity option. I can just put one probe here and the second one here. I should get, as you can see, the continuity in the multimeter. This one, the same working principle, one probe here, the other probe here, as you can see. So, do you see here? We have 3 amps over here, 250 volt. So, this is the maximum voltage and amps that this fuse can support. Okay, so its function is protection. Okay, for this fuse, for example, we have 3 amps, okay, and 250 volt. So this fuse is blown out, is damaged, because it could be the current that pass 3 amps or the voltage that pass 250. Okay, that's why this one is burned out. So to test it, as you can see here, we're gonna just put one probe here, as you can see, and the other probe here. Do you see? Nothing. Normally we should get a continuity here, but we didn't get anything. So let's check, for example, this one, the good one. Okay, so one probe here and the second probe here. Do you see? We get 0 ohm in the multimeter. For this one, for example, this kind of capacitor, so its symbol is like this, as you can see. This one or this one. But for this kind of capacitors, as you can see, its symbol, as you can see, is the same as this one, but we have here plus, as you can see. Because those capacitors are polarized capacitors. You can also find another kind of symbol, basically this symbol, without plus here, but this one means minus. Okay, so the reference is C for this kind and this kind, or sometimes you can find BC or BC. As you can see here, we have C9 here, over here C9. Okay, and for the fuse that we have seen before, we have its symbol, as you can see here, and we have F1. This is basically the fuse. Okay, and for the capacitor, we have here C9. The same also for the motherboard, as you can see, we have here, over here, we have C514. Okay, so to test this capacitor, as you can see, let's take this one, for example, using the continuity option. I can just put one probe here, as you can see, and the other probe here. So focus in the multimeter, as you can see. Do you see the capacitor charge and discharge, as you can see? Do you see? Charge and discharge means this capacitor is a good capacitor. Hi everyone. So in this video, I'm going to teach you electronic components, names, functions, symbols, and testing using the multimeter. Okay, so here we have a lot of electronic components. Of course, I'm going to teach you this electronic component that I have here and also others. So please, this is a very important video, especially for beginners. You gotta understand everything about electronic components. So let's get started. But please, before diving into details, make sure you subscribe and click the notification bell to stay updated for future videos like this one. For anyone who wants to join me in my Patreon page, you are very welcome. I can be your mentor in my Patreon page, and I can even give you my WhatsApp number if you become a mentorship experience member. So let's dive into the course. So first of all, because this course, I made especially this course for beginners, I will first of all explain to you the multimeter a little bit. So this is the multimeter, as you can see here, this is a digital multimeter. Okay, so here, as you can see, we have the diode and the continuity option. So usually we use this option in order to test diode or to test the continuity. We can also use it to test inductors capacitors, etc. So here we have the resistance, as you can see. We have 200 ohm, we have 2 kilo ohm, 20 kilo ohm, etc. So here, for example, you should pay attention. If you want, for example, to test a resistor with 10 ohm, you should select this option here. If you want, for example, to test a 300 ohm, okay, you should not select this one. You should go and select always the higher value, okay? And here, as you can see, we have basically the voltage. This is continuous voltage. If you want, for example, to check like this, as you can see, battery, or to check a DC voltage in the motherboard, we're gonna see all this. And here, as you can see, we have the alternating voltage. If you want to check, for example, an alternating voltage, here we have amps, okay, in alternating voltage and in continuous voltage, and here we have the farad if you want to check a capacitor, okay? And for the transistors, you can use this one, but I prefer to use probes, okay, for NPN and PNP transistor. This is just a quick explanation about the multimeter. And always the read probe, do not forget the read probe. You should always put it here where we have V, and here the black one in the common probe, as you can see here. And if you want to measure the amps, okay, then you should move on this probe here if you want to test milliamps, or to this probe if you want to test amps under 20 amps. Okay, so let's get started. So as I told you, we gotta see names, functions, symbols, and testing. So let's begin, for example, with the inductor. Okay, here this one basically we called it inductor or coil. Okay, you can find this type or even these types also, as you can see. Basically, we find this one in the desktop motherboard, and also you can find this one in the desktop motherboard, and this one in switch mode power supply board, like this one, for example. Okay, and for this two, you can find it in the desktop motherboard, like this one, for example, or this one, as you can see over here. So the name, this is inductor or coil. So we called it inductor, okay, inductor or coil. Okay, so this is inductor or coil. Okay, so for the function, the inductors and coils are usually used to adjust the current in the circuit. Okay, that's why we find it in the output. For example, here you can find an inductor like this is basically the symbol, and then here a capacitor that is connected to the ground, an electrolytic capacitor like this one or like this one. This one we find it, as you can see, in switch mode power supplies like this. And this kind, we find it, as you can see, this kind of capacitor, we find it in motherboards like this one, as you can see over here. Okay? So then here you will get, for example, output. For example, 5 volts. Okay? So the inductor, its reference is L. Okay, the reference is L. Okay, we can also add here reference. Okay, so the name is inductor or coil. The reference is L. You can find L in the motherboard or PL. So as we have here, if you focus here, we have L. Do you see L15 for this inductor? We have here, as you can see, L53 for this inductor. Okay, so the function is to stabilize the current. Usually it increases the current in the circuit. Okay, and for the symbol, this is the symbol for inductor. Okay, and for how to test inductor, easy. You can just use the multimeter and you should select the continuity option, since the inductor is just a wire. Okay, so let's select the continuity option in the multimeter. Okay, so let's check if the continuity is selected correctly, as you can see. Okay, so let's begin with this one. For example, for this one here, this is one inductor. I can just put one probe here, and the second one here, I should get, as you can see, the continuity in the multimeter. This one, the same working principle, one probe here, the other probe here, as you can see. So for this one, basically, it contains, as you can see, two inductors. Do you see a different color? This is the first inductor, the red one, and here the orange one is the second inductor. So this is the first inductor, these two, and here we have the second inductor. So let's check it. So one probe here and the other here. So let's check one probe here and the second here, as you can see in the multimeter. So let's check the second one here also, this inductor also. So one probe here, as you can see, and the other here, and the second probe here, as you can see in the multimeter. So these two inductors are good. So let's put the inductors here. So this is good for inductor. So let's see another component. So let's see, for example, the fuse. Do you see? Here we have two fuses, as you can see, and we have here another fuse. This is basically a burned fuse. So for the name, we have fuse. The reference always for the fuse, as you can see, its reference. So this is basically, as you can see here, the symbol for the fuse. You can find F. So the reference is F, or sometimes you can find PF sometimes. Okay, you can find this symbol or even this symbol, as you can see, like resistor. Also, this is the symbol for the fuse. For the function, its function is protection. It protects the circuit from high current. That's why we find over here, if you focus here, as you can see, so let's see. Do you see here? We have 3 amps over here, 250 volt. So this is the maximum voltage and amps that this fuse can support. Okay, so its function is protection. Okay, for this fuse, for example, we have 3 amps, okay, and 250 volt. So this fuse is blown out, is damaged, because it could be the current that pass 3 amps or the voltage that pass 250. Okay, that's why this one is burned out. So to test it, as you can see here, we're gonna just put one probe here, as you can see, and the other probe here. Do you see? Nothing. Normally we should get a continuity here, but we didn't get anything. So let's check, for example, this one, the good one. Okay, so one probe here and the second probe here. Do you see? We get 0 ohm in the multimeter. Let's check this one also. I don't know if this one is good or not. Let's check. This one also is good, but this one, as you can see, is burned. Okay, do you see the thin wire here? Do you see the thin wire? Here we have a wire inside it. So this is it for the fuse. So the reference, as you can see, is F or PF. The name is fuse. We called it fuse. Okay, like this. So the function is protection. The symbol, this is basically the symbol, this one or this one. And to test it, we test it using the multimeter and using the continuity option. Okay. So So let's move on right now to another component, so the capacitor, as you can see here. Here we have many capacitors, as you can see. Let's gather this component in one side, okay? So now we're gonna see these capacitors. Basically, we have two kinds of capacitors: the ceramic capacitors and electrolytic capacitors, okay? So these capacitors, these two and this one, we find it in the switchboard power supplies, like this one, for example, here, okay? Or this card also, we have capacitors here, as you can see. And this kind of capacitor, as I told you before, we find it here, as you can see, in motherboards, okay? So how can, so for the capacitor, for this one, for example, this kind of capacitor, so its symbol is like this, as you can see, this one or this one. But for this kind of capacitors, as you can see, its symbol, as you can see, is the same as this one, but we have here plus, as you can see, because those capacitors are polarized capacitors. You can also find another kind of symbol, basically this symbol, without plus here, but this one means minus, okay? So we use these capacitors to filter, for filtering purposes. Those also, we use it also for filtering, but especially we remove the noise, okay? The noise in the circuit. But this one, in order to transform, as you can see, the alternating current to DC current. Okay? So the reference is C for this kind and this kind, or sometimes you can find BC or BC for, as you can see here. As you can see here, we have C9 here, over here C9, okay? And for the fuse that we have seen before, we have its symbol, as you can see here, and we have F1. This is basically the fuse, okay? And for the capacitor, we have here C9. The same also for the motherboard, as you can see, we have here, over here, we have C514, okay? So we have seen the reference. So we have seen the reference, names, okay, function, okay, the filter, it filters the current, the symbols, this is basically symbols, and testing. So let's now check these capacitors. Basically, to check these capacitors, we can use, as you can see over here, we can use the continuity option, or directly we can use the farad. Here we can test it using this option. Let's first use the continuity option. So to test this capacitor, as you can see, let's take this one, for example. Using the continuity option, I can just put one probe here, as you can see, and the other probe here. So focus in the multimeter, as you can see. Do you see the capacitor charge and discharge, as you can see? Do you see? Charge and discharge means this capacitor is a good capacitor. Okay? So let's check, for example, the ceramic capacitor here. We should not get a continuity. If you get a continuity like this, means the capacitor is bad. So let's check. So this is a good one. Let's check this one also. So this capacity also is good. Let's check this one also. You see, charge and discharge. This one also is good. Okay, so we can use the continuity option, or we can use, as you can see, these options where we have nanofarad and microfarad. So let's pick, for example, any capacitor here. This one, for example. Okay, so before using this option here, you should make sure that you know the capacitance of the capacitor. Here we have 400 volt 22 microfarad. So we should find here 22 microfarad or 24, 21, no problem. So let's go to the multimeter and set the multimeter to microfarad. Here we have 2 microfarad. Normally in the capacitor we have 22, as you can see. So we should go to the second option. The higher value, always the higher value, as you can see here. Do you see in the multimeter we have 2? We should go to a higher option, as you can see here. We have 200 in the multimeter, we have 200 microfarad. Why? Because we have 22 in the capacitor. Always you should select the higher option than that component contain. Okay? So let's check it right now. So here we have the negative terminal. Over here we're gonna put the black probe here, as you can see, okay? And the red probe in the other side. Nothing in the multimeter. So let's check another capacitor. I bring another capacitor. This capacitor, for example, how we have here, as you can see, 150 microfarads. And I have another one here. We have 47 microfarads. So let's check. Okay. We have the negative terminal over here and the positive terminal here. So nothing, it could be the multimeter. I don't know, it could be the multimeter. So let's check this one also. So nothing in the multimeter. So the problem, it could be the multimeter. Anyway, so for the capacitor, as I told you, we have seen the reference, C or PC. We have seen its name is capacitor. The function, as you can see, the filter, it is used for filtering purposes. The symbol, here we have the symbols for electrolytic capacitor and symbol for ceramic capacitor. And here, so here I can even, here we have ceramic, okay, ceramic capacitor. Okay, and here we have electrolytic capacitor. Okay, and for testing we have testing it. Okay, so let's see another component. So basically here we have, as you can see, the next component that we have is the bridge rectifier. Do you see? Here we have bridge rectifier. So basically the bridge rectifier, as you can see here, contain 4 terminals. Okay, so here we have plus, here we have minus, and here we have EC, as you can see, plus, minus, EC. So to test this bridge rectifier, you should always put the negative probe in the positive terminal, the inverse, or put the red probe in the negative terminal and test with these 2 pins. You should find 2 diodes. So let's do it. So let's check this one first. So as you can see here, we have plus. So I gotta put the black probe here. Here I should find a diode, 500 or 600. So first let's go to diode option. As you can see here, we have diode option. Do you see? 500 drop voltage. We have the first diode. Here we have the second diode. Okay? If we swap the probes, as you can see, if I put the positive probe in the positive terminal, nothing in the multimeter, nothing in the multimeter, means the bridge rectifier is good. Let's check this also, as you can see. So here we have the positive terminal. Okay, I should put the red probe here, as you can see, the black probe in the positive terminal. So let's make like this, okay, and this probe once here we get the first diode drop voltage. Let's check this probe also, as you can see. If I swap the probes using the same working principle, as you can see, nothing in the multimeter, nothing in the multimeter. Okay, So this is also a good bridge rectifier. So this is bridge rectifier. We called it basically, okay, bridge, okay, the bridge, okay, or a rectifier. Okay, rectifier. So its function basically, it's exactly like the capacitor. Is, as you can see, when we have the alternating voltage like this one, after it is applied to the rectifier over here, we get, as you can see here, a continuous voltage. It's not a continuous 100%, but we get just the positive alternance. Okay, and when this positive alternance is applied to this capacitor, as you can see, to the capacitor, okay, we get this voltage, as you can see here. We get like this voltage, DC voltage, okay? So the function for the symbols, here is the symbol. You can find just one diode like this one, or for this kind of bridge rectifier, basically we have 4 diodes. As you can see, this is the first diode, this is the second diode, as you can see over here, and then we have the third diode, and then, as you can see, we have here the fourth diode. Here, basically, we have plus, okay? This plus here, this is the plus connected, as you can see, to the capacitor, and the capacitor connected to the ground. And here we have minus, okay? That is connected directly to the ground. Okay, so this is the symbol for the bridge rectifier. So for testing, we have testing, okay? So I hope that you enjoyed the video. So basically, we're gonna see other components in the next video, maybe tomorrow or after tomorrow. So basically, this is the crystal oscillator, as you can see here. The crystal oscillator, this is its reference, as you can see, for the crystal oscillator. So the symbol, basically, its reference could be X or Y. Okay, we're gonna see it. So then we have the transformer, as you can see. The transformer could be like this. Okay, it contains many inductors inside it. Then we have the relay. Always the relay, you're gonna find one inductor and a switch. And a switch, as you can see. This is basically the relay. We can also see how to test it. Then we have the Schottky diode. Here we have its symbol over here, okay? And the MOSFET, basically, the MOSFET, as you can see, we have always drain, okay? And we have gate and drain. And here we have source. I'm going to teach you also the MOSFET, etc. In the next part, I'm going to continue explaining to you other components. Basically, I have a lot of components that I'm going to teach you, as you can see, one by one. Okay? I'm going to teach you all this kind of components. So we're gonna see the reference, name, function, symbols, and testing. So please guys, don't forget to subscribe, share the video, and like the video, because your likes and engagement motivate me to create more and more videos for you. And for anyone who wants to join me in my Patreon page, feel free to join me, and I can be your mentor. For anyone who wants me as a mentor, I can help you fix your computers or laptops using WhatsApp number, of course. And of course, if you select the mentorship experience. Thank you very much, and see you in the next video. Hi everyone, so please pay attention. This is a very important video where I'm going to teach you how to test all types of SMD components on laptop motherboard. Upon completion of this video, you will be able to test any SMD component on any laptop motherboard. But please, before diving into the course, make sure you subscribe and click the notification bell to stay updated for future videos like this one. And of course, for anyone who wants to join me in my Patreon page, you are very welcome. I can be your mentor in my Patreon page and assist you via WhatsApp until you fix any computer problem you have. So let's get started. So basically, guys, here we have mini motherboards. So of course, I'm going to teach you how to test SMD components. When I say SMD components, I mean, as you can see here, MOSFETs, ceramic capacitors, as you can see here, inductors, electrolytic capacitors, Zener diodes, resistors, MOSFETs and transistors, tantalum capacitors, ICs, etc. So let's get started. So let's choose the continuity here, as you can see here, and check first diodes, inductors, and ceramic capacitors. Okay. So let's begin from the input here. For example, we have, as you can see here, ceramic capacitor. So to test ceramic capacitors, it's easy. Of course, you can use the continuity option in the multimeter. So if you find any buzzer or any low resistance here, it means the capacitor is shorted. So let's check these two, for example, these two ceramic capacitors. As you can see in this multimeter, this is a good capacitor. Let's check the signal also. Here also, this is a good capacitor. If you find like this, as you can see, means the capacitor is bad. Okay. Here, basically, as you can see over here, this is inductor, not diode. Why? Because we have here PL. Okay, we have PL over here. So let's check this inductor. I should get a continuity in the multimeter. As you can see in the multimeter, means the inductor is good. So here we have two MOSFETs. Basically, we have two MOSFETs. How we can check the MOSFET? So to know about MOSFETs, do you see here this hole over here? Means this is the pin number 1, pin number 2, pin number 3, 4, etc. So always the 3 pins here are source. The 4th pin and gate, and the other 4 pins are drain. So these 3 pins are connected together. If you want, we can even check. So let's put the probe here and check with the 2nd pin, as you can see, and the 3rd pin, as you can see. So these 3 pins are connected together, but this is the gate. It's not connected with the other 3 pins. And over here, these 4 pins are connected together. Why? Because this is the drain. So let's check. This is the 2nd pin, the 3rd pin, and the 4th pin, as you can see. So 4 pins connected together. So if you want basically to check whether the MOSFET is good or not in the motherboard without removing it, you can just put one probe here in the source, the multimeter, and the other probe here. As you can see, we get a reading, as you can see in the multimeter, about 500 drop voltage. Means this MOSFET is good, it's not shorted. We can do the same for this one also. So first, let's spot the first pin. Where is the first pin? Here we have the hole over here. Means this is the first pin, the 2nd, the 3rd one. So these 3 are source. This is the gate, and over here we have drain. So we should always check between drain and source. As you can see, we should find a drop voltage about 500, 400, no problem. It's the same as you test a diode. Okay. So these two MOSFETs are good. Now let's move on to this, basically to this component. Do you see this component? This is basically current sense resistor. Okay, so this current sense resistor basically is a resistor with a very low resistance. Means if you check it using the multimeter and choosing, as you can see here, the buzzer or the continuity option, you should get a buzzer or a very low resistance like this. So let's check it, as you can see in the multimeter. Okay. So here basically this is inductor. So this is one type of inductor. Over here we have another type of inductor. This is a very big inductor. Always this type of inductors are connected to power rails. You can never find inductors that are connected to ground. Never in the motherboards. So that's why we use inductors to find out the short circuit in the motherboard. So let's check this inductor. Also the same working principle. For the inductor we should get, as you can see here, a very low resistance in the multimeter, as you can see. Means this inductor is good. Here also we have another inductor. Let's check it also. This inductor over here, also low resistance. Do you see this inductor? Basically here we have the high pins and over here we have low. Here we have, as you can see, these two are ground and these two, as you can see, are positive terminals. This, the 19 volt, pass exactly through this inductor. So we can even check. So if I put, for example, one probe here, you see, one probe here, and check here, do you see? So the 19 volt will pass directly here and then pass through this inductor and goes to the side of the inductor. Okay, that's why you should always pay attention to inductors in every circuit, because inductors, if there is a bad inductor, means a cut inductor, the voltage will stop passing to other side and you will get a dead motherboard. So let's move on here. As you can see, we have basically a Zener diode. Do you see the Zener diode over here? So to check the Zener diode, we should always spot and identify the cathode. Here we have the cathode. Do you see this black line? Means this is the cathode. So we're gonna put the black probe of the multimeter in the cathode and the red probe in the anode. We should find here a drop voltage about 500, 400, 600. So let's check. As you can see, 586 drop voltage means this is a good Zener diode. So please, here I want to add that this is not Zener diode. Normally this is not a Zener diode. This is a normal diode. Why? Because we have here a black line. Sorry, this is a normal diode. I will show you the right Zener diode. So let's find out here a motherboard where I have some Zener diodes. Okay, so let's check this motherboard over here. Let's check this motherboard. Okay, this is great. Okay, find the Zener diode over here. So do you see, guys? So this is basically the normal diode. Do you see? Here we have this black line. We have the reference D, means this is normal diode. Here we have cathode and over here we have anode. But for this one, as you can see here, this is Zener diode. Why? Because we have the blue line. When you find a blue line like this one, means this is Zener diode. This also is Zener diode. Okay, but for this, as you can see here, this one, this is a normal diode. We have the black line. So then we can move on. Here basically we have other two inductors. So let's check these inductors. We should get a continuity. As you can see, we have the first diode, the first inductor, and as you can see, the second inductor here. So this is good inductors. So then, as you can see here, we have PQ67. This is basically a three-terminal MOSFET. A three-terminal MOSFET. So here we have gate, source, and drain. Always for this kind of MOSFET, you will find gate, source, and drain. So let's check it. Basically, we should find a drop voltage of about 500 or 600. So let's put the black probe here in the source and the red probe in the gate, in the drain. As you can see, we get 596, means this is a good MOSFET. So let's check this one also. As I told you before, usually or always you will find here, this is basically the gate. Here we have the source and here we have the drain. So let's check again. So here, as you can see, the black probe and over here the red probe. So let's check. I get a reading, as you can see, in the multimeter. But if I swap the probes, I should not get any reading in the multimeter. As you can see, no reading in the multimeter. Okay, it's the same like if we check a diode. Okay, the same as a diode, as a Zener diode. As you can see, we get here a reading when we put the black probe into cathode and the red probe into anode, And once we swap the probes, nothing in the multimeter, as you can see. Okay. So then let's pass and check other things. So we're gonna right now check this capacitors. Basically, this is electrolytic capacitors. But first, this kind of component are also like this and like this one. This is inductors. Always for inductors, you should find a continuity, as you can see here, for inductors. Okay, now let's check this kind of capacitors. This is basically electrolytic capacitors. The purpose of electrolytic capacitors is to filter the current in the circuit, okay, to make a pure current and a a DC. Okay, so it converts, okay, in addition, of course, of the bridge rectifier or the rectifier, it converts the alternating current to DC current. I already made a lot of videos, many videos about this topic. So let's check. So this mark over here, as you can see, means this is the negative terminal. Okay, this is minus. And over here we have plus, as you can see, we have plus here. The same for this one. Negative terminal, positive terminal. So we can also use the continuity option to check all kind of ceramic capacitors. Okay, so we can just put one probe here, the cathode terminal here, as you can see, in the negative terminal, and the positive one in the positive terminal. Do you see? The capacitor charge and discharge, as you can see. The capacitor charge and discharge means the capacitor is good. Let's check this one also. We should find the same. The capacitor should charge and discharge. Oh, here we have a short. Is it a short or not? Let's check this one. This one is good. The capacitor charge and discharge. So let's check this one again. We have a short. No. Guys, this is not a short. Here we have a trick that you should understand. I will share with you this very important tip that many technicians don't know about this kind of shorts, as you can see. We can find this one also with the same reading, as you can see. Is it a short? No. Also, this inductor, as you can see, will give the same reading in the multimeter. So if we put the black probe here and the red probe here, as you can see, you see? This is not a short. This is basically the resistance of the processor. Because the processor is installed in the motherboard, we get, as you can see, this value. So let's check this motherboard, for example. So if we check between ground, as you can see here, and these two inductors, this inductors basically belong to CPU circuit. If we check, as you can see here, you see we get a low reading, as you can see. But if I remove the CPU, here I will not get this reading. I will get a very increased reading. It could be 100 or more. So let's remove the CPU. Now the CPU is removed, as you can see. So let's check again now. So the black probe here in the ground. Let's check the inductor. Do you see? Do you see? We get a high reading. Let's check this one also. Do you see? But if I put back the processor, I will be back to very low reading. So I can even put this, the black probe here, and this, as you can see, the red probe here, and do it in a real time. So I will put the processor. So let's put the processor to its place, as you can see. So let's unscrew this screw, and you will see that the short is back. Do you see? Once, okay, let's loose the screw also. Do you see? The short is GA. Basically, it's not short, but it's the CPU resistance. Let's do it again for the last time. Do you see? As when I close this one, the short is back. Okay, guys, so when you check, so remember, when you check component around the CPU or even around the graphic cards, around the GMCH or graphic card, you will usually find a very low resistance. This resistance that you find is not a short circuit. It's not a short circuit. That's just the resistance of the chipset, including CPU, GMCH, and ICH. The real short is this one, like this. In the multimeter, you get 0. Okay, this is the short. But if you get like this reading, this is not a short. This is the resistor, the resistance for the CPU. So let's move on and check other component. For example, this component, this is capacitor. This is, we call it tantalum capacitor. Also, this kind of capacitor is a polarized capacitor. Here we have, as you can see, this bar here means this is the positive terminal. Here we have plus, and over here we have minus. So let's check it. We're gonna put here the red probe and here the black probe, as you can see, the capacitor charge and discharge, as you can see. The capacitor charge and discharge means the capacitor is good. Okay, let's check another one. For example, here we have other two capacitors. Let's check it using the same working principle. As you can see, do you see here we have C, the reference. C means this is the capacitor. We call it tantalum capacitor. Oh, do you see? The same. Is it a short? No, because this capacitor belongs to the CPU circuit. This is the back of the CPU. We get this reading. It's not a short. This one also should give the same reading, as you can see. But this one, no. Why? As you can see, because this one didn't belong to CPU circuit. Here we have CPU circuit, where we have capacitor and MOSFETs, capacitor and MOSFETs. And over here we have the IC, the processor or the CPU IC. This one belongs to another circuit here. Okay? Now I'm going to teach you how to test ICs. Let's, for example, take this IC. For example, this is the audio control IC that controls the audio. Okay, so how can we check this IC? Basically, you can check this IC or any other IC using three methods that I already shared with you in the previous videos. The first method is by checking the heat of the IC. If you find while powering on the motherboard that the IC is very hot, its heat is not normal, means the IC is bad. The second method is by checking the ceramic capacitors around it. If you find any capacitor that is shorted in both sides, means automatically the IC is shorted. Okay, so for the ceramic capacitors around every IC, you will find that the ceramic capacitor, the terminal of ceramic capacitor in one side is connected to the ground, as you can see, and in the other side connected to the IC, as you can see. But if you find this capacitor is shorted, means the IC is shorted to the ground. Let's check this one. For example, it's not shorted, means the IC is good. Let's check this one. Also, it's not shorted, but this capacitor always is connected to the ground, as you can see, in one side. Do you see? Do you see in the multimeter? Okay, and connected to IC in this side, in the other side, as you can see. Okay, I will draw for you. So I will draw for you the schematic for this IC and capacitors in order to understand clearly. So do you see? Here is the IC, as you can see. This is the IC basically. Okay, this one is the IC, as you can see over here. And for every IC, you will find ceramic capacitors around it. There will ceramic capacitors around it. Okay, so the ceramic capacitor is connected to the IC in one side, okay, and to the ground in the other side. So if you find any shorted capacitor, means the IC is connected directly to the ground. Okay, so any shorted capacitor means the IC is connected to the ground, not here but in the other side, because the IC connected to the ground in many of its pins. Okay, so this is the second method that you can use to check whether the IC is bad or not. The third method is by checking the inputs of the IC. So for example, let's assume here that this IC will generate 3.3 volt in pin, for example 19. So to generate this 3.3 volt, the IC should receive some input signals. This is basically input, as you can see, signals. Okay, including enable signal here, 3.3 volt, and the VCC 5 volt, for example. If these two signals are missing, the IC cannot generate the 3.3 volt. So if you didn't find the 3.3 volt, it's not means 100% that the IC is bad. No, you should first check the inputs. If inputs are good, so 100% the IC is bad. So this is it, guys. I hope that you enjoyed the video. Please stay tuned for more videos like this one, and please make sure that you subscribe and you click the notification bell to stay updated for future videos. And don't forget, please like and share video with other people like you. And of course, as I told you before, for anyone who want to join me in my Patreon page, where you can find many useful and exclusive content, including free schematic, laptop schematic, and computer schematic that you can upload or download for free, and of course many tips and tricks and secrets that you can use to repair your computer failures. And for anyone who wants me as a mentor, I can be your mentor and assist you and help you until you solve all computer and laptop problems you have. Of course, if you join me in my Patreon page as a mentorship experience member. Thank you very much, and see you in the next video. We have Q22. This is a transistor, and always we have the base, okay, base, collector, emitter. So between collector and emitter, we have a reading. Okay, so this is a good transistor. If we swap the probes, of course, we should not get any reading, as you can see. A 100 resistor, 100 means basically 10 ohm, because the third number is number of 0, so 10 ohm. If we check it, do you see? We have 10 ohm. This is current sense resistor, usually about 2 ohm, 2.2. Do you see? 2.4. This one also 2.6. So this is cathode here, and here we have anode. We should get a reading. Do you see? We have a reading. If we swap the probe, normally we should not get a reading. But here, because the diode is connected to the board, we get a reading, as you can see. Capacitors, do you see? For 10 turn capacitor, we have 12. For MOSFET, we have 12. Also, for the inductor with the ground, as you can see, we will get 12. As you can see, this is not a short circuit. This is the resistance for the CPU. I can even remove the CPU, as you can see. If the CPU is removed, if I check the 10 turn capacitor, we have a high reading. For the inductor with the ground, we have a high reading, as you can see. Also, the MOSFET, we have a high reading. So, once we connect back the CPU, we will get again the same reading. For the 10 turn capacitor, we have 12 for the MOSFET. If we test the MOSFET between source and drain, we have 12. Also for the inductor and the ground, we have 12, as you can see. This is not a short circuit because this capacitor belongs to CPU circuit. But for capacitors, in other circuits, you should not get a low resistance, as you can see. Hi again, so welcome to another video where I'm going to teach you how to test SMD components on laptop motherboards. So I'm going to use the continuity option for the majority of components that we're gonna test. So let's select the continuity option here, or the diode option, as you can see. So let's begin with MOSFETs. As you can see here, we have three types of MOSFET. We have this kind of MOSFET. This is SMD MOSFET. Of course, here we have source, drain, and we have the gate. We have also this kind of MOSFET. We called it flat SMD MOSFET. We find it usually next to the CPU. So, of course, here also we have source. This is gate and this is drain. Do you see? Source, 3 pins connected together, and always we locate the source with this dot over here, as you can see, or this white mark. Always the pin number 1, 2, 3 are for source. Okay, and of course we have also this kind of MOSFET. As you can see here, we have source, of course, and here we have drain. So if we check this MOSFET, for example, let's begin with this one. We can just put the black probe here in the source and the red probe in the drain. So we have a reading. Okay, we have a reading. If we swap the probes, normally we should not get a reading, but here we get a reading because the MOSFET is connected to the board. Okay, so let's see, for example, those MOSFET also here. So we have here source and here we have drain. We get a reading about 500 drop voltage. If we swap the probes, as you can see, we get another reading because the MOSFET is connected to the board. Here basically we have other MOSFET. Those MOSFET is for CPU. Let's check between drain and source. Normally those MOSFET should give a very low resistance. Let's see. Do you see in the multimeter we have 13 or 20? This is not a short. This is because we have the CPU here. So always for the CPU circuit, you will get a low reading, as you can see. The same also for this one, you will get a low reading. Do you see? A low reading. So 12 is the resistor for the CPU, because always for the CPU and chipsets, okay, and chipsets like those, the resistance is very low because they work in a fast way. So if the resistance is higher for chipsets and processor, so the data will not be transferred in a fast way. That's why always for chipsets and processor we find a low resistance. So this is for MOSFETs. So of course, next to this MOSFETs, the capacitors or the tantalum capacitors are polarized. As you can see, always we have here plus and minus.
Please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials. CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project, and if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCBWay. Now back to the video.
But for the CPU, for those capacitors in the CPU circuit, we're gonna get the same resistance as we get in the MOSFET. Do you see? The same resistance. Okay? This resistance, this is not a short circuit, this is the resistance for the CPU. So same for capacitors, do you see? For 10 turn on capacitor we have 12. For MOSFET we have 12. Also for the inductor with the ground, as you can see, we will get 12. As you can see, do you see? So we get 12. Do you see? We get 12 for the inductor. We get also 12 when testing the capacitor, and also we get 12 when testing the MOSFET. The same resistance. The resistance is for the CPU. So please pay attention to this tip. This is not a short circuit. This is the resistance for the CPU. And another time for beginner to be sure, I can even remove the CPU. As you can see, if I remove the CPU like this, if I remove the CPU, okay, the CPU is removed. If I check now the 10 turn capacitor, we have a high reading in the multimeter. For the inductor with the ground, we have a high reading, as you can see. Also, the MOSFET, we have a high reading. So once we connect back the CPU, and of course lock the CPU screw, we will get again the same reading. For the 10 turn capacitor, we have 12. For the MOSFET, if we test the MOSFET between source and drain, we have 12. Also for the inductor and the ground, we have 12, as you can see. And of course, 10 turn capacitor, we have 12. Okay, so this is the resistance for CPU, the same for chipsets also. You will find same thing for chipsets. For ceramic capacitors, you should not get a continuity. You see, this is a good ceramic capacitor. This one also is a good one. This one also is a good one, etc. We have many kind of ceramic capacitor. Those are ceramic capacitor. This one also is ceramic capacitor. Here we have ceramic capacitor, etc. But always the ceramic capacitors belong to CPU circuit. You're gonna find always a low reading, as you can see. This is not a short circuit because this capacitor belongs to CPU circuit, always the same working principle. But for capacitors, in other circuits, you should not get a low resistance, as you can see. You should always get a reading, as you can see. Okay, so this is for capacitors. And of course, to test inductors, of course, inductor is just a wire like this. Inductor is a wire, so you should get a continuity, a zero reading. So this is good. If you didn't get a continuity, it means the inductor is failed. The same for this resistor, this zero resistor, or this shunt resistors where we have zero, the same as inductors. You should get a low resistance, as you can see. Okay, of course, this kind of resistor you can test it using the continuity option or the resistance option. Please pay attention. You can find some component, asymptotic component like ceramic capacitors. This one, for example, this is not a capacitor. This is a ceramic capacitor. Here we get a reading. Do you see? But this is not a ceramic capacitor. We should get zero reading. Do you see? Why? Because this is inductor. So this is inductor. This is inductor. As you can see, we get zero. This one also is inductor. But those are capacitors. This is capacitors. This one is capacitor. This one also is capacitor. But this one is, as you can see, inductor. Do you see this brown or a little bit black color? This is inductor. So do not confuse between inductors like this one and capacitor. This is inductor, this is capacitor. So those kind of component, this is diode. Always locate this white mark, this is cathode here, and here we have anode. We should get a reading. Do you see? We have a reading. If we swap the probe, normally we should not get a reading. But here, because the diode is connected to the board, we get a reading, as you can see. No problem. This is a good diode. We have here another diode. Always, as I told you, locate the white mark. The white mark is the cathode. And here we have the anode. We get a reading, you see? 500, 600. If we swap the probes, as you can see, we get another reading. No problem, because the diode is connected. Let's check. This is basically, those are transistors, 3-terminal transistor. It could be also MOSFET, but those are transistors, and this is HP MOSFET. This is crystal. This is IC. Here, guys, do you see? Over here, we have capacitor, capacitor, inductor, inductor, capacitor, capacitor. Do you see? Here we have a shunt resistor. We should get a 0 reading. Here we have capacitor. We should get a high reading, low reading, because this is inductor, low reading, inductor, high reading, capacitor, high reading, capacitor, high reading, capacitor, okay, inductor, low reading. This is a shunt resistor. Okay, so please try to do not confuse between Zener capacitors and inductors like those. And for ICs, of course, to test the ICs, you should have a schematic and know about the inputs and outputs. But you can just check the Zener capacitors around the IC. If you didn't find a short circuit, means you didn't find shorted capacitors, means the IC is good. Also, you should check the IC using your finger. If you feel that the IC is very hot, is hot above normal, means the IC is bad. Or if you find shorted capacitors, Zener capacitors, means also the IC is bad. And of course, this is a rule. All ICs you will find, as you can see, Zener capacitors around it. Do you see this IC also? We have Zener capacitors around it. All ICs. So for tantalum capacitor, guys, please pay attention. For tantalum capacitor, this is another motherboard. You can find tantalum capacitor like this, as you can see, like those yellow, or like this one, as you can see over here. But the same working principle. Always you should not get a low reading, as you can see, for tantalum capacitor, unless in the CPU circuit you can get a low reading. So here, guys, this is a transistor. This one we have Q22. This is a transistor, and always we have the base, okay, base, collector, emitter. So between collector and emitter we have a reading. Okay, so this is a good transistor. If we swap the probes, of course, we should not get any reading, as you can see. Okay, and this one, this is a fuse. Okay, this is a fuse. We have even here F1. So let's check this fuse. We get a low reading in the multimeter. So this is a good fuse. Here, of course, we have other transistor. Always here we have base, collector, emitter. Always between collector and emitter you should get a reading. But if you swap the probes, as you can see, no reading, or you can get a reading because the transistor is connected to the board. This is basically electrolytic capacitor. For electrolytic capacitor, always we have plus here and minus. So this is the positive terminal and the negative terminal. This is polarized component. So of course, the same working principle, we should not get any reading. But because here this is the processor, we get a low reading. This is not bad, this is good. But if we move on, for example, to this one here, we should get a high reading. As you can see, a high reading. Do you see? We get a high reading. But as I told you, always near to the chipset and the processor, the low reading is good, is not bad. Let's check right now the resistance. Here, for example, we have a 100 resistor. 100 means basically 10 ohm, because the third number is number of 0. So 10 ohm. If we check it, do you see? About 10, we have 10 ohm, as you can see. For this resistor, for example, we have 2R2, about 2.2 volt. So 4.6, about, so 4.6, approximately. So here we have this kind of resistor, this one, and this one, we called it, do you see, we have R. This is current sense resistor, usually about 2 ohm, 2.2. Do you see? 2.4. This one also, this is a very low resistance, 2.6. So basically, the purpose of this resistance is to measure the current consumed by the motherboard. Those basically, we called it network resistor, and we find the value above it. The network resistor gather many resistors. It could be 4, 5, or 3. And the purpose of this network resistors, as you can see here, is basically to gain the space in the motherboard. So let's check, for example, this network resistor. Do you see we have, this is a network resistor. We have 103. So always the third number 3 is 3 zeros, means 10K or 10 kilo ohm. Okay, so let's check. We have 40, about 10K. Okay, as you can see. And always, as you can see, I choose here 20K. Always try to choose the higher, the higher value. If you want to check a 1K, you should check 2K. If you want, for example, to measure 100 ohm resistor, choose this one. But if you want to measure 100K, use this one. Okay, so thank you very much. I appreciate your attention, and please don't forget to subscribe, like the video, and for anyone who wants to join me in my Patreon page, you are very welcome, and see you in the next video.
So I'm going to teach you how to test all components of the motherboard without removing it from the board. This is a very exclusive course. Please don't miss this video. Stay tuned until the end, because what I'm going to teach you will impress you. So let's begin with this capacitor. For example, we have 10 ohm capacitor. So let's check. We have a reading in the multimeter, means good. Let's check this one also. We have ready, good. So please, testing component is very easy. Let's check this diode. Here we have, for diode, this is a Zener diode. We should locate the cathode. Here we have the cathode. Do you see this white mark? Means I'm going to put in the cathode the black probe like this, and the red probe in the anode. We have a reading. If I switch the probes, let's see. Nothing. In the multimeter, means this is a good Zener. Let's check ceramic capacitors. Here, for example, we have ceramic capacitors. Let's check. So no continuity, as you can see. So no continuity means this is good ceramic capacitors. So for inductor, of course, we should get a continuity, as you can see. We should get a continuity because the inductor is just a wire. Let's see the MOSFET. Here we have the MOSFET. So for the MOSFET, we should locate first. Here we have the source, okay? Here we have the drain. So if we check between drain and source, we should get a reading. If we swap the probes, we get also a reading. This is normal. Why? Because the MOSFET is connected to the board. But once we don't get a continuity like this, means the MOSFET is good. Let's check this MOSFET also. Let's check between drain and source. As you can see, nothing in the multimeter. If we swap the probe, we should get a reading about 400, 500, 600. Do you see? Good. So this is a good MOSFET. Let's check this MOSFET also, just to be sure. Here we get a reading. If we swap the probe, we get a reading because it is connected to the board. This one also, the last one. Swap the probe. Good. This is good MOSFETs. Okay. What about the resistor? So we have here 103, means this is a 10K or kilo ohm resistor, because 3 here means 3 zeros. So this is 10K. So for resistors, we cannot test it using
the continuity option, we should move to 20K. Okay, always a value that is higher than the value here. So let's check. We should find 10K. Do you see? We have 10. We have 9 or 10K. So this is a good resistor. So let's go to continuity option and check this diode over here. Do you see, guys? This is diode. We have D21. So always for diode, we should locate the cathode and put the black probe into cathode like this and the red probe into anode. We get a reading in the multimeter. If we swap the probe, we should get nothing. As you can see, nothing in the multimeter means this is a good diode. So here we have MOSFETs. So what about the IC, guys? What about the IC? How we can test the IC? Please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials. CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project. And if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCBWay. Now back to the video. So easy, you can test the IC by checking the ceramic capacitors around the IC. You see, we get a reading. Good. But if you get a short circuit like this on those ceramic capacitors, means the IC is bad, because usually the ceramic capacitors are connected to the IC in one side and to the ground in the other side. But please pay attention for the chipset circuits. Okay, so if we go back here, please pay attention. This is a very important. So here, this is basically the back of the processor. Okay, here we have the back of the processor. So I told you that for the ceramic capacitor, we should not get a continuity, as you can see in the multimeter. So this is good. But we have exception for the processor. Do you see? We will get a continuity, as you can see. Do you see? We will get a continuity. But this is, we have 13. This is normal. Okay, so this is normal for the CPU circuit. Please pay attention to this. This is not short. Okay, this is not short, guys. Okay, this is normal for the CPU circuit. Okay, but the same also here. If we put the black probe in the ground and check this inductor, do you see? Do you see, guys? We get a low. Do you see? We get a low reading. But if I remove this CPU, we will get a high reading. Okay, so do you see? Now we have a low reading. So let's remove the CPU. So let me please remove the CPU. Okay, now the CPU is here. So let's check again the black probe in the ground and check. Do you see? We get a high reading. Here we get a high reading. So if we put the CPU back, okay, so let's put the CPU back. Okay, now the CPU is good. Here I have the CPU. Let's check again. Low reading. So the resistance is for the CPU, means we don't have a short. So please pay attention for the CPU, for the NOT bridge, the PCH. Always the component in the back of this chipset, you will get a low resistance, but it's that this doesn't mean that we have a short circuit. But for other circuits, okay, for other circuits and other ceramic capacitors, we should not get a continuity, just for chipsets. So I hope that you understand what I'm saying. So please, we're gonna continue. After, I'm going to continue with you and check other component. Thank you very much. This is just a fast video. So we're gonna continue in other videos checking other component. Of course, I'm going to teach you how to check components on the board like this and outside the board. So just stay tuned. Please subscribe and hit the bell icon for future videos like this one. And please
like the video and share it with other people like yourself. And for anyone who want to join me in my Patreon page, you are very welcome. You can join me. You will find a lot of schematics that you can download for free, and of course a lot of exclusive content that I didn't share here in YouTube. And of course you will find all links in the description, the link for my Patreon page, for gift page, for my PayPal, for anyone who want to support the channel, for my website. Okay, a lot of links. Thank you very much and see you in the next video. I'm going to teach you how to test every component here using, of course, the multimeter. So let's begin with this diode. So here we have this white mark over here, means over here we have cathode and here we have anode. So we're gonna put one probe here in the cathode and the other probe in the anode. We get a reading in the multimeter. This is a good diode. Always for the MOSFET between drain and source, you should get a reading, as you can see in the multimeter. Do you see? The capacitor charge and discharge means this is good capacitor. If you use the continuity option, you will find about 0 in the multimeter, or you can test it using the resistance option. So if I check this resistor, I can find about 1 ohm. It could be less or it could be high a little bit, 1.2, 1 ohm or 0.9 ohm. Do you see? 1 ohm, about 1 ohm. So this is a good current sense resistor. Here we have another current sense resistor. If we check it, about the same value, 1 ohm, 1.1. Let's check. We have 1.1, 1 ohm, 0.9. So this is good. The dot means this is what? This is here the emitter, collector, and base. So for transistor, between emitter and collector, we should get a reading, as you can see. If we swap the probes, normally we should not get anything, as you can see, nothing. Okay, the same for this one. So we have this dot, means this is emitter. So between emitter and collector, nothing, good. But if I swap the probes, I should get a reading between collector and emitter. Let's check. I get a reading about 600. For ceramic capacitor, we should get a high reading, as you can see in the multimeter. If you get a short or a low reading like this, means the capacitor is shorted or the IC near to the capacitor is shorted. Let's check those also. Good, good. Hi everyone, so welcome again to another strong video where I'm going to teach you how to test all this component in this motherboard one by one. So I'm going to teach you how to test every component here using, of course, the multimeter and of course in the other side of this motherboard. So please stay tuned because this video will help you a lot during your hardware repair. So without wasting time, let's get started. So first of all, I'm going to select the continuity option, and of course here we have the diode option because this is the option that we're gonna use to test the majority of component in the motherboard. So as you can see here, this motherboard is for HP, and over here we have the input or the DC input, and here of course we have the diode. So let's begin with this diode. So here we have this white mark over here, means over here we have cathode and here we have anode. So we're gonna put one probe here, as you can see, into cathode, good, and the other probe into anode. We get a reading into multimeter. This is a good diode. Of course, if we swap the probes, normally we should not get anything in the multimeter. This is good. So this is a good diode. This diode basically is used for protection. Then over here we have a MOSFET. This is a 3-terminal MOSFET. Do you see? 3-terminal MOSFET. And over here we have 8 MOSFETs. I'm going to test all these components just step by step. So here we have gate, as you can see over here, we have drain and source. So always for the MOSFET between drain and source, you should get a reading, as you can see, in the multimeter. If we swap the probes, as you can see, we didn't get any reading, means this is a good MOSFET. So please guys, I'm going to teach you right now. I teach you how to test component very fastly. Okay, so this course or this video will be very important, especially for beginners. Please do not skip any moment in this video and stay tuned until the end, because I'm going to check all these components in this motherboard, okay, in the entire motherboard. And of course, I show you how to test the majority of components using just the continuity and the diode option in the multimeter. So let's check this capacitor. Basically here, if you focus here, we have 220 microfarad, 6.3 volt. This is the characteristics of this capacitor. Okay, so note that this is a polarized capacitor. Do you see? We have here plus over here, and this color means minus. Here also for this one, we have minus, and over here we have plus, minus, plus. So to check this capacitor, you can just put the black probe here in the negative terminal and the red probe in the positive terminal. Do you see? We get a reading in the multimeter. We didn't get a continuity like this. If you get a continuity, means there is a problem in the capacitor. This one also, for example, let's check it. We get a reading. This one also, as you can see, we get nothing. If we swap the probes, let's check. Do you see? The capacitor charge and discharge. Okay, the capacitor charge and discharge. Do you see? Means this is good capacitor. Do you see, guys? So this is how we can test this kind of capacitors. We called it electrolytic capacitor or polarized capacitors, because we have here plus and here we have minus. For this component, this is basically, we called it inductor. The inductor basically is just a wire. Okay, the inductor is just a wire. If you try to look here, do you see the wire here inside the inductor? Means we should get a continuity while testing the inductor. Do you see? 0 in the multimeter. Means this is a good inductor. If you didn't get a continuity or a buzzer like this, means there is a problem in this inductor, and you should of course replace it using the same reference, 2R5. Okay, please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials. CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project, and if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCBWay. Now back to the video. For this one, for example, we have 2R2, 2R5. This one has 6R8, etc. This is the reference
that you can use to replace those inductors. Now let's move on to this kind of MOSFET. This is basically 8 MOSFETs, the same as 3-terminal MOSFET. But here, as you can see, you should usually or always locate the pin number 1. Do you see here we have a small hole, or of course you can use this dot. Do you see this white dot? This white dot means this is the pin number 1, pin number 2, pin number 3. Okay, so 3 pins for source. We can ever check these 3 pins. You're gonna find the continuity. Do you see? The first pin and the second and the third. Do you see, guys? We have continuity between these 3 pins. And this one, this is the gate, the 4th pair, and the other pins here are for drain. Also for beginners, we can even check the continuity. All these pins are connected together, as you can see. Okay, all those pins are connected together. So all these 4 pins are just like the drain here, and these 3 pins are like the source over here, and the gate, this is the gate here, and this is the gate. So to check this kind of MOSFET, easy, exactly like this MOSFET, as you can see. We can just check between drain and source, as you can see. We get a reading, means this is good MOSFET. For this one also, we can check between drain and source. We get a reading, this is good. Those also the same, we get a reading. If we swap the probes, we get a reading here. Also here, we get a reading, means these 4 MOSFETs are good. If you hear any buzzer like this, means the MOSFET is shorted. So for the inductor, the same as this one, we should get a continuity. Okay? Here we have the tantalum capacitor. We called this component a tantalum capacitor, and it's also polarized exactly like this one, as you can see, like the electrolytic capacitor. And over here we have the capacitance, 227 microfarad. And over here, this white mark means this is the positive terminal, and over here we have the negative terminal. Do you see? We get a reading, means this is good. We get a reading, means this is good. If we swap the probes, do you see charge and discharge? Do you see, guys? We have charge and discharge. Means also the tantalum capacitor, or this capacitor, is a good capacitor. Good. Now let's move on. So this is MOSFET. So in order to do not waste time, to test this MOSFET is exactly like this one. So we're gonna pass to other component. Of course, we can test it fastly here. So we get a reading, means this is good. Okay, here we have basically ceramic capacitors. We're gonna test it. Here we have inductors. This is not ceramic capacitor. We have inductors. Here we have current sense resistor. Basically the current sense resistor, you can test it here using the continuity option. Okay, if you use the continuity option, you will find about 0 in the multimeter, or you can test it using the resistance option. If we, for example, select 200 ohm, of course, if you have a digital multimeter, you can select the auto range in your multimeter. But for me, I have this kind of multimeter, so if I select 200 ohm, so please, sorry for my voice. So if I check this resistor, I can find about 1 ohm. It could be less or it could be high a little bit, 1.2, 1 ohm, or 0.9 volts or ohm. Do you see? 1 ohm, about 1 ohm. So this is a good current sense resistor. Here we have another current sense resistor. If we check it about the same value, 1 ohm, 1.1, let's check. We have 1.1, 1 ohm, 0.9. So this is good. So these 2 current sense resistors are good. So basically, the current sense resistor here, this is the main current sense resistor. its purpose is to measure the current consumed by the whole motherboard, okay? And for this one, the same purpose, but it measures the current consumed by the battery, okay? So then let's check these transistors. Over here we have some transistors, so we should pass always to diode option here to test transistors. So of course for transistor we have, as you can see here, the dot means this is what? This is here the emitter, collector and base. So for transistor, between emitter and collector we should get a reading, as you can see. If we swap the probes, normally we should not get anything, as you can see, nothing, okay? The same for this one. So we have this dot means this is emitter, so between emitter and collector nothing, good. But if I swap the probes, I should get a reading between collector and emitter. Let's check. I get a reading about 600, okay? So this is a good transistor. So what about the ceramic capacitor? So ceramic capacitor, of course, the same. We should get a higher reading. For ceramic capacitor, we should get a high reading, as you can see in the multimeter. If you get a short or a low reading like this, means the capacitor is shorted or the IC near to the capacitor is shorted. Let's check those also. Good, good. But please pay attention for this component over here. This is not capacitor. Do you see? Do you see the color about a little bit brown or black color? This is inductor. If we check it, if we test it, we will hear a buzzer. You see, 0 in the multimeter. This one also 0 in the multimeter. So this is inductor and this is ceramic capacitors. So let's check other components. Here basically we have inductor, here we have MOSFET. So those also are MOSFETs. We have here 8 P MOSFETs. Also this one, we called it flat SMD MOSFET. The same working principle. Do you see we have a dot here, means the 3 pins over here for source. We have the gate and we have the drain. So if we check between source and drain, of course we should get a reading. As you can see, we get a reading. Do you see? About 500. But if I swap the probes, normally I should not get anything in the multimeter. As you can see, means this is a good MOSFET. The same for this one. So over here we have diodes. Do you see? This is normal diodes. We have D over here, D25, D27. Do you see this white mark? This white mark means this is cathode here, and here we have anode. We get a reading about 200. If I swap the probes, of course, I should not get anything here. This is a good diode. For this one also, you should always locate the cathode. We have the cathode over here because we have this white mark. So here we have cathode, as you can see. We get a reading. If I swap the probes, of course, I should not give nothing in the multimeter. This is good diode, okay? The same, we have another here. We can even check it. We get a reading. Good. So here, basically for the BIOS, we cannot test it using the multimeter. To test the BIOS, we should power basically the motherboard and check the pin number 8 of the BIOS. Do you see here? We have this dot, means this is the pin number 1, 2, 3, 4, 5, 6, 7, 8. So always for BIOS, in pin number 8, you should find 3.3 volt. If you find 3.3 volt, the motherboard should turn on without any problem. This is how we can test the BIOS. If the 3.3 volt is present here and all power rail in the motherboard are good, and you get, for example, the black screen, means you should reprogram the BIOS. So let's check other components. So we check already MOSFETs, inductors, ceramic capacitor. We have here electronic capacitor, 390 microfarad, 2.5 volt. So this, as you can see here, this circuit, basically we have inductor, capacitor, MOSFET. This is the circuit for the RAM. We can even check if we put, for example, one probe here in this inductor and check the RAM here, you're gonna find a continuity. Okay, we're gonna find a continuity. We should find a pin that is connected directly, as you can see. Do you see, guys? Do you see? So this pin over here, the pin 71 here, do you see pin 71 is connected directly to this inductor. So the RAM slot receives the voltage in this pin, pin 71, and the voltage, of course, is 1.5 volt, as you can see. Okay, 1.5 volt. This is how you can locate the circuit. Of course, for example, here, for the battery circuit, here we have the positive terminals and here we have ground. So here we have ground, as you can see, you see, and here positive. So between the positive terminal and those two inductors, I should get a reading. I should get a continuity. Do you see? We get a continuity. Okay, so this is how you can know the inductor that feeds the circuit. So these two inductor feed this connector, this inductor feed the RAM slots, and also these two inductor feeds the CPU circuit. You can even check if I put one probe here and one probe here. Do you see? We have a continuity. The two inductor feed the CPU. Do you see? Here. This is how you can know about circuits. And for this inductor, this is basically for VCCP, about 0.5 volt. This inductor, the VCCP, is sent to the CPU, do you see? And also sent to the graphic card, do you see? Here. And also to this, to the source bridge. Do you see, guys? So the VCCP here feed the CPU, the graphic card, and the source bridge. This is basically just a tip about how you can identify the circuits of a motherboard. So let's check if we have another component that we didn't test. So here basically this is a ceramic capacitor. I told you that for ceramic capacitor you should get a high reading in the multimeter. Okay, if you get a short circuit like this or a continuity means the capacitor is bad. Here, as you can see, we have a 10 ohm capacitor. If we check, we should see some charge and discharge of this 10 ohm capacitor, as you can see. Means this is good. So let's see the other side of the motherboard if we have some component that we can test. So let's see, for example, resistors. Do you see we have here a resistor? We have here, as you can see, we have 2, 2, and 0. Okay, always the third number is the number of 0. So means this inductor, the value of this inductor is 22 ohm. So let's check. So 22 ohm. So let's put the multimeter to 200 ohm. Always select the high value. So let's check if we can find 22 ohm or not. We should find 22 ohm in the multimeter. Do you see? We have 22 ohm. Because the 0, the third number always is the number of zeros. We have 22 ohm in the multimeter. Means this is a good resistor. So this kind of component, this is a fuse. We should get a continuity. So this kind of component, this is a fuse. We should get a continuity in the multimeter. So this is good. So that's it, guys. So for ICs, guys, you can just check the ceramic capacitors around the IC. If you find that ceramic capacitors around the IC are not shorted, means the IC is not shorted 100%, or you can just touch the IC using your finger while the motherboard is working. If you feel, for example, that the heat of the IC is normal, that's good.
And by the way, for anyone who wants to download this PDF file, you will find the link in the description, the link of my Patreon page, where you're gonna find this PDF file
and many others. Other content. You can download many schematics for free. Of course, a lot of schematics. You need just to join me in my Patreon page, and you will find a lot of exclusive content that I didn't share here in YouTube. And of course, here in my channel, for new subscriber or new member, you are very welcome. You're gonna find in my channel a lot of videos about did motherboard repairs, about schematics, about how to diagnose the motherboard, about also the electronic component, hardware, how to test components, so samples, a lot of videos that you will help you to understand. Of course, here I have a membership for anyone who want to join me in my membership, and also you can find many useful links, like the link for example for my Patreon page, for the gift page, the link also for my PayPal for anyone who want to support me, for my website, etc. A lot of links, and of course a lot of videos, and of course you gotta find even the live videos and the complete courses. Thank you very much.